Mr. or Ma'am Al-Harbi Nada Muhammad Said, you are raising your hand. Is there any question?
No, just I'm not understand the Malaysian language.
Okay. Okay, could you please mute your, okay. All right. Again, before we begin, please mute your mic so we can continue. Thank you. Peserta yang dihormati sekalian, izinkan saya untuk memperkenalkan penceramah kita pada hari ini. Ladies and gentlemen, allow me to introduce our speaker today. Profesor Madya Rohana Alias merupakan pensyarah yang mempunyai 35 tahun pengalaman dalam bidang beliau. Our speaker today has 35 years of experience in her field. Berlatar belakangkan Master of Sciences in Mathematics, penekanan dalam bidang sains dalam bidang statistik dari Western Illinois University. She has Master of Sciences in Mathematics from Western Illinois University. Beliau kini menumpukan kemahiran beliau di dalam bidang numeracy and statistical analysis. Untuk sesi pagi ini, Profesor Madya Rohana akan menyampaikan sesi yang bertajuk Introduction to IBM SPSS dan subtopik-subtopik yang akan dibentangkan adalah the subtopics for today's session. For introduction to IBM SPSS would be data preparation, data screening, and exploratory statistic. Dengan ini, saya ingin mempersilakan Yang dihormati Profesor Madya Rohana Alias untuk memulakan sesi beliau. Persilakan.
Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Alhamdulillah. Wassalatu wassalamu ala rasulillah wa ala alihi wa sahbihi ajma'in. Selamat pagi and very good morning to everyone. Thank you for being here. So as the moderator told just now, that we are going to have a session on introduction to IBM SPSS. Since we have somebody from not from Malaysia, so maybe majority of the session will be conducted in English, and if anybody require explanation in Malay, I can switch the language, inshallah. So without further delay, I would like to share my screen. I hope everybody can see the screen now. We're going to start our session to introduce the IBM SPSS. Now, the overview of the session will be a short introduction to SPSS, and then we will go into data preparation, and then the third one, there's typing error there, sorry, data screening, and the last one is exploratory statistics. Okay, I hope everybody is not too alien from SPSS, but SPSS is actually first launched in 1968, but has been acquired by IBM in 2009, and now known as IBM SPSS Statistics. However, I think majority still use the word SPSS. The main thing about SPSS is it's actually a software used for editing and analyzing data. So that's the main use. Okay, let's look at the main features in SPSS. In terms of window, the three major windows or the most popular window is the data editor window, and then we have output viewer window. And then another window is syntax window, but we will not be covering it today. And others will include chart editor, text output editor, pivot table editor, and we will look at various menus and toolbars. Now, how many of you are already familiar with Excel? Anybody familiar with Excel? So if you have used Excel before, SPSS is almost like Excel in the sense that it is a spreadsheet, but we have two windows here. For data editor window, we have two views. If you look at what I'm pointing now, we have data view and variable view. So that is for data editor. Now the data view is basically telling you or showing you the actual data. Data sebenarnya adalah dalam data view. Now we have here in columns. So the columns here are referring to variables. So each column refer to one different variable. And the first row, similar to Excel, is actually used for the variable names. And then rows are for cases. Now, if your research is collecting data from respondents, now each row will represent one respondent. That means for Ali, we have the data being entered in the one row. For example, for Ali, I put an ID for him as number 1. So row 1 here is representing all information that we collected from Ali. If you take measurements from using instrument, any kind of physical instrument, then it is maybe about one item. So one item, if you collect several variables for them, then it means it is given in the rows. Now the values here, the data here, the data that we type in the cell is actually called values. So values here, if you notice, we have in terms of numerical values, numbers, and we have also typewritten alphabets here. Now, here we have in the third column is dates. So we can have various values for the data cell. All right, that is the overview of the data view. Next, we go to the variable view. Now, for variable view, we have the names for the variable. Now, it is like a dictionary where it tells you what your variables are. So if you look here, in the rows are the variables. Okay, and the variable name is given in the first column. Right? And the third thing that I want to touch now is about the labeling of the variable. It means some variable is clear-cut by the name. For example, gender, you know gender represents gender. But when you write some symbol or short form for the variable like edu here, edu is referring to the education level. All right? Okay, so the label is telling you what is the actual variable is about. And then the fourth thing that I'm going to mention is about the values. The values here describe the meaning of the value that you enter. For example, if we have entered, let me go back to the slide before. Here, notice that for job category here, it is written 3, 1, and so on. So what is 3 representing? What is 1 representing? That is given in the value labels here. Okay, the values will tell you the meaning of the value that you have entered in the data. Right? I hope everybody is following. if you have any question or you want me to go any slower, you can write in the chat box. I'm opening two PC here. One is to look at the chat given by the audience. All right.
Yes, there are requests for you to go a little bit slower because we have beginners in our session today.
All right. Okay. Now, about what we have covered just now, let me just recap. The overview that I'm giving you is as an introduction, and then later we will have a set of data that we will go through and do it practically. So I hope everybody has installed already the SPSS software. If your version is different from what I'm going to use, that is okay because there is a little bit difference in each of the version. All right, any questions so far for what we have shown here? The data is entered in the data view, and the labeling, the information about the data that you have entered will be given in the variable view. Now, as to the different types of information in the variable view, we will go through it afterwards. All right, the next one that is in the list just now is the output viewer window. Here the window is will be showing all your results. The analysis that you run or the graph that you have run, all will be given in the output viewer window. Different from Excel. If you have used Excel, when you run an output, it will be in the same window. So that's the difference here between SPSS and Excel. The next one is the output editor. Output editor is basically giving you the opportunity to edit your chart. What you need to do is you go to the chart and double click. And once you double click, it will be highlighted, and then the changes or the modification that you want to do in terms of labeling and so on can be done there. All right, the next one is the text output editor. We can write different text to label either the title or even the labeling for the x-axis and y-axis. So that is the text output editor. And then the next one is the pivot table editor. Now, for the table that is produced in the output of SPSS, you can edit in terms of the presentation that you need to put in your paper or in your report. What you need to do is you double click on the table. At the table, you will double click and it will show you this bar here in the menu bar, which is pivoting table, and also it gives you the diagram. You can go and use the command here, or you can use the diagram to do the changes. You can change the color, you can arrange the rows and columns, and you can hide certain things or delete things that you do not want from the table. All right, we will try to do this later. Okay, so as for any software, you will have the menu bar and the toolbar. I'm going to quickly run through some of the things in the toolbar first, and then for the menu bar, we will go through when we open a file. So it's easier for you to see, all right? Now, for the toolbar, you notice some of the diagram is very clear, and it is similar to like our Microsoft Windows icon, like open the file, save the file for this one, and printing. That is very clear. Okay, and the others here that is maybe a little bit different is we have a dialog recall. Anything that you do in the session, it will be listed here. So if you do not want to click the menu bar, you can go to the dialog recall and reuse the command. All right. And then here the undo and the forward, this is the same like what we have in Windows. Here for the icon here, the colored one is showing you at the row. So this is going to case. Remember, case is representing a person or any element that you are collecting data from, or if you are doing time series, it may be referring to a certain time period. But this is the case. And you can also go to the variable. The icon shows you the arrow is to the column. And then the variable information is given in the next icon. You can also run the descriptive statistics by clicking the next icon. And if you notice here, the diagram is darkened a little bit. You need to go and highlight on the variable, then only it will be highlighted, and then you can run the descriptive analysis. Okay, I hope we will go through this one afterwards to make it more clear. And then the next icon is the find. To find any values, you can go to this icon, and we can split data file. We can select cases. Now, if for any analysis that you want to analyze only certain part of your data, then you can go and select cases and then analyze. But after that, if you want to analyze the whole set, you can deselect the cases, right? And then we have the value labels. Remember just now that in the variable view, we have value labels. You can see in your data editor, if you want to look at the labels, you can simply click here. All right. Now the menu bar, the file, edit, view, we will go through later. All right. Now let's go into the data file. So now can everybody, let me go. We want to open the SPSS file given to you by the admin. All right. So I will escape from here. We want to open SPSS. Let me show you my entire screen for now. Okay, Nurul Izhawati, are you trying to ask something? Okay, can you see my screen now? I'm clicking here.
Yes, we can see your screen.
Okay. My SPSS, I don't save it at the desktop, so I'm opening from here. My SPSS is version 25, right? So you click open like just any other program. You click it. It's a bit slow this morning. All right, it's opening now. Okay, my version is like this. So yours might appear a little bit different if your version is a previous one. So what I want you to open now is the employee data. Okay, I'm opening it from SPSS. Yours should be in the data file. Okay, you just double click or you can click open here. Right. Okay, so now you can see the data file. So we have a typewritten data file here, and then we have the data view and the variable view. So here is the information about the variable. So you can go from the data view to the variable view. All right. Any questions so far? Now, to open, you just click open, and if you want to save the data, you click file, you click at save as, and then you can save the data. If you want to do it now, you can just simply make a change in the name, maybe employee data 1 or whatever you would like. Just rename and then click save. Okay, it will save to wherever you put your data. All right, that is to open and to save the SPSS data file.
Prof, we have someone who asked you if you could please repeat on how to enter the data.
All right, we are going to enter a data now in the second module. We are going to the second module now. Okay, let me show you the slide. And we will repeat whatever I say just now practically, so it will be easier for you to see. All right. Okay, we have opened and saved the data. Now the module 2 is actually on data preparation. Here is where we want to create the data set, and we will also learn how to import data from Excel, since I think many of us is quite familiar with Excel. So the example of the data set is the one that you are looking at now in your SPSS. This is an example of a questionnaire which we are going to use to enter the data. We are going to learn how to name the variable and put values to the information that we want, and also key in data, right? Now, for this questionnaire, this do not refer to any specific questionnaire. I just came up with this example so that we have various form of information. We have also here the Likert scale type of data with 5 points, right? So we will now go through the defining of the variable. How to create the data set, we need to define the variable, which include we name the variable. We also give a label for the variable. That means if we have chose a name is a short form, Now we need to be able to understand what is the variable about. We need to give a label for the variable. And then we will put value labels, which is giving numeric codes for the variable values. For example, just now for gender, we have female and male. You can either enter it as it is, male, female, type written, or you can represent it with numbers. So this is what we mean by giving value labels. You will use numbers to represent the values that is given in the question. And then we will see about missing values. Missing values is if a response is not received from the respondent, or if you get your data from the experiment, the data is missing somehow, or if you take secondary data, the data is not available, so you might be representing it as missing value. And then we have also variable type. We either put it as numeric, string, dates, as we have shown just now, or there are quite a number of variable types given in SPSS. And then we have also the column format where we can adjust the width depending on whether the information you want to write a sentence or just numbers, we can change that. And then we have measurement level. We will talk a little bit about this one. In SPSS, we have 3 types of measurement level, which is ordinal, nominal, and also scale. Scale here is interval and ratio measurement level. Now, if you're not familiar with this one, it's okay. I will go through this one also. But this is just to tell you that when we want to create SPSS, a data set, this is what we need to decide to put or about our variable. And then next step is just to enter the data. Okay, now about the names of the variable. It must start with a letter. You cannot start with a number, right? And then the remaining characters can be a letter or digit or symbols. Notice here that we can use these few symbols, but you cannot have a space in the names, right? Like if you have educational level, you cannot write education and then space level. You cannot do that, but you can use the dash here to represent the space if you want. And then you cannot duplicate names. That means one variable have a unique name. You cannot have one name for 2 variables. You cannot have that. Here, blank and special characters not allowed. Length of the name cannot exceed 64 bytes, which is about 64 characters. We will do the defining of the variable for our example of the questionnaire just now. This is the example of the variable definition that we're going to do. The name of the variable, the type that I say that we're going to do, and then the width, we can specify the width, this number of decimal place that you want to set for your data, and then the labeling of the variable just now. And then this is the value labels, where we tell what is the data that you entered, what is the detail about it. And you can define missing values. The columns here, how many characters you want. If you want a longer one, you can change the number. How you want to see the data, whether it is a line or not, you can also represent here. And then here is about the measurement level. I will cover this one also. Okay, about the variable type, the most common one is the string and numeric variable, but the other types is given here. If you notice here, we have comma, dot, scientific notation, date, and so on. But most of the time, we just represent it either numeric or string. Okay, string means it is not numbers. Anything that you type, for example, you type Malay, Chinese, automatically the variable type is set to string. If you type numbers like 1, 2, then automatically it will be labeled as numeric. For example, if you have gender just now, if you type male, female, then it will become string. But if you represent male as number 1, female as number 2, then it will be assigned as numeric, and you need to go and change the variable type, or not the variable type, the measurement level data. All right?
Prof,
Yes.
Arzia here.
Yeah.
If I can ask, when you put gender male as 1 and female as 2, meaning is it male number 1 and female number 2, or is it just assign male itself as number 1?
You just give a label. That means you assign 1 as male and 2 as female, and we will write or enter the information for that assignment in the value label. So it is just a representation, because you will not want to write male, and it is quite a long.
I see. Okay.
You have to type male or female is quite long. So
Alright.
usually you will represent it with numbers.
Okay, understood, Prof. Thank you.
Oh, thank you. Okay. To define the value labels like just now, male and female, here our example is using F and M. But we can have, like I said just now, 1 and 2. Here is where you will define the labels. You, under column values, you go to whatever variable that you want, like here, the highlighted one is for job category. You can double click at the 3 dots here. It will give you this dialog box. Okay, and then you can assign. Here is already assigned value. We will practice it afterwards on our example. For example, if you write 1, you will label clerical, and then you click add. And then you go to the next one, you write 2 is for custodial, and then add. You will do that. Here for, I'm not sure the data set here is given in SPSS. What's the reason that the researcher want to indicate 0 as missing? For missing values, you have a number of reasons why you want to define sometimes different numbers to indicate different type of missing values. Okay, let's go to the missing values definition. Notice here, if you do not define anything for missing, like what we write here, none, if you do not define anything, when you don't have the information for that particular variable, the system automatically represent it with a dot. Okay, the system will automatically give a dot for it. When a non-response variable in a questionnaire, for example, you do not put 0 unless you want to. Like just now, if we define here 0 as missing, then you can type 0. Otherwise, you will just keep for that particular variable and move to the next one. The system will automatically assign a dot. If you need to assign different kind of labels for different type of missing values, for example, if a person refuse to answer, you want to assign 99. But if a person skip to answer, then you want to assign 77. Now the numbers you decide here can be any number, but you make sure that the data set for that particular variable do not contain that same number lah. For example, if you have age, you know age of a person is cannot go beyond 200. I don't think there's anybody of age 200. So any number greater than 200 can be used to assign the missing value. Right? The numbers usually used are 999, 888, like that. Okay, so it is easily identified. But you need to tell SPSS that it refers to a missing value. Any questions so far?
No, Prof.
All right. And then the next important thing that we need to look at is the measure. The measure, as we have mentioned just now, we have only 3 categories in SPSS. Even though in mathematics or statistics, we have 4 levels: the ordinal, nominal, and interval and ratio. But here, the scale is for interval and ratio type of measurement. Okay, so now let's look at this information on measurement level. This is very important because SPSS will allow you to analyze almost anything, but what makes it decide that it is a correct one is based on your the measurement that you have indicated in the variable view. The type of analysis, the type of measurement, central measure of central tendency that you can use will depend on this one, the measurement scale. So we will review now for measurement. What do we mean by measurement? It's actually a number, number which are to represent the characteristic of the object. Now, a simple example here, as we have mentioned, female we assign 1, male we assign 2. So these number 1 and 2 do not represent the normal mathematical numbers. Now, if in normal numbers, you can add 1 and 2 and divide by 2, for example, and get 1.5. 1 plus 2 divided by 2, you get 1.5. But what 1.5, what does it mean in our definition for here now? 1 is female, 2 is male. 1.5 is representing what? It has no meaning. We are not. We are excluding all the other new defined gender that we have nowadays. But 1.5 or 1.25 has no meaning. You cannot add and divide numbers like the mathematics operation. So, but there are the 4 different types of scale just now. Measurement scale will tell us which numbers can be added, which can be subtracted, divided, or multiplied. That's why the information is important. You can also assign, for example, strongly disagree 1, disagree 2, 3 neutral, 4 agree, 5 strongly agree. So those are measurement, right? So how do we collect data? You either administer some instrument. Now, I look at your information that you give in the survey that the admin given you. Majority of you, I think, wants to use correlation. There are some time series analysis required and t-test and whatnot. But there are also some from social sciences which may or may not use a questionnaire. Okay, so when you administer a questionnaire, you can, that is an instrument, but for that kind of instrument, you need to check the reliability and validity of the instrument. Okay, either you come up with your own instrument, or you use existing instrument and modify accordingly to the different cultural values and so on. And you can also record data from secondary data, any data that is available, or you collect it from an experiment. For example, you measure temperature from using a physical instrument. You can also do that. So if you notice, there are two types of variables. One is a clear-cut variable like the gender, occupation, marital status. That is clear-cut. The answer is very clear. And you also have variables like weight, height, and temperature, where you use a physical measuring device, instrument. Okay. However, there are some nebulous variable like attitude, satisfaction, motivation. This is something abstract that you want to measure, and to do that, you need to operationalize it to measure the behavior or the characteristic. This kind of variable need to be you must be very careful in checking the validity and the reliability of the measurement that you use or the instrument that you use. Okay, now the four types of measurement scale we have is the nominal. The lower level is the nominal, the ordinal, and then the next one, internal and ratio. The internal and ratio under SPSS is the one that we say just now is labeled as scale. All right. Now here is a little guideline given for identifying what the variable is, what the measurement level for a specific variable. Now the question you can ask are given here in this diagram that I have taken from the source here. You check whether order is important. We check about the fixed unit measurement, and we check about whether zero means zero or not. Okay, so now we will go through this one and discuss what nominal means, what ordinal, and so on. What is it referring to? The example given here is, for example, nominal is when you ask about favorite animal, maybe you say a cat, maybe fish, whatever. That is the numbers that you represent, like the gender just now. The number that you use is the scale. Number 1 is for male, number 2 is for the female. 1 and 2 are scale just to name the category. 1 for cat, 2 for dog, 3 for fish. So that number 1, 2, 3 is just to label, to name. So that's why the scale is called nominal. Here the nominal, maybe a cue word that you can use to remember is to name. The number is to name. For example, if you look at the sportsman, a basketball, maybe a football athlete, they will have a number at the back of their shirt. That number is just to name. So it is a nominal variable. It is a nominal category type. But if you have some kind of order or ranking, for example, you have bad, neutral, good, there is order. Or you have strongly agree, strongly agree, neutral, disagree, strongly disagree, there are order there. So it will be under ordinal variable. Interval and ratio, the main difference is actually with this question here, 0. Is 0 indicating nothing? If 0 has a meaning of true 0, maknanya kosong tu memang makna tak ada apa-apa. Kosong makna tak ada apa-apa. 0 means nothing. That means you call that true 0. For example, if I ask you how many pen you have, you say 0. That means 0, that means none. You don't have anything. 0. That is a true 0. If the true 0 exists, it falls under ratio variable. It falls under ratio. But if you have 0 which do not indicate true 0, for example, the classic or the most common used example to explain the interval type of scale is about temperature. If you measure anything and it gives you a measurement of 0 degrees, 0 degrees Celsius, the 0 means no temperature or the temperature is 0. Like if I ask you how many pen you have, you don't have anything. That means that is true 0. But if the temperature gives you a reading of 0 degrees Celsius, does that mean no temperature?
Temperature is 0.
The temperature is 0. That means that is not a true 0. The reading is 0, but that doesn't mean that it is no temperature. Let me take another example. If you are measuring student performance by using the CGPA, if you get a student with a 0 CGPA, does that mean that they do not have any knowledge or they don't learn anything? The 0 means that they don't learn anything. That 0 do not mean that the student do not have any knowledge or do not acquire any knowledge. That is not a true 0. So that will become interval variable. So interval variable do not allow division and multiplication. All right, let us go to the information here, the example here. In the next slide here. Okay, there is an example here given in the chat box here. We will go and look at that later. Okay. The scale here, this is nominal because as I mentioned just now, the number 1, 2, 3, 4 is just to represent the category. So that is very clear, just to name. And if for ordinal, there is order or ranking. So if you ask a worker, for example, to rank the usage of a computer, by assigning 1 most used, 2 next most used, and so on, that will become an ordinal scale because that is order or ranking. Now, for this first question, lecturers are usually dominated with monologue without revealing the application of what is being taught. All right. So strongly disagree, and so on. These are the 5-point Likert scale for respondents to choose from. Now, one is strongly disagree, two disagree. This is ordinal type of scale. Now, usually a question will arise for using Likert scale type of instrument. People will ask, is this considered ordinal or interval? If you look at one particular question, for example, the first question here, this is ordinal. The second question is also ordinal because it's ordered. The answer, the numbers that you choose, either 1, 2, 3, or 4, or 5, is ordered, or there is ranking. So this is ordinal. Now, if you sum the score or combine the score, then it will become interval scale. For example, we have, afterwards we will do this also. We will add the 3 questions here and divide by 3 to get the mean. So that value now is considered interval scale. And it will allow you to calculate mean, standard deviation, and so on. Okay, so that is interval scale. Ratio scale is also very easy to understand because it gives you exact figures. For example, if you ask a person how many other organizations did you work before joining the system, maybe the answer is 0, 1, 2, 3. So that is very clear-cut answer. And 0, if you answer 0 here, it means you don't have any you do not work at any other organization. So 0 means true 0. So does all the other question here, how many retail outlets do you operate? This is also ratio. Please indicate the number of children you have in the following categories. This is one question each. Either you answer 0, 1, 2, 3. If you write 0, that means you do not have any children below 3 years of age. 0 means nothing. So it becomes ratio. So any question about this one, the 4 types of scale? Because this is very important. It will determine what type of measures, descriptive statistics that you can use to describe the variable, and also the test that you are allowed to use. Now, as much as possible, you would like it to be either in interval or ratio scale, because that is more statistical analysis allowed for that kind of scale.
Assalamualaikum.
Waalaikumsalam.
Can I conclude like this? Nominal is not ranking, ordinal is ranking, interval not true 0, ratio true 0.
Yeah, okay, you can do that. Now, if you want to, if you have ordinal type of scale, you cannot subtract 2 numbers. Similar also with nominal, you just now cannot add 1 plus 2 divided by 2. You cannot do that with the numbers because it's just to label. For ordinal also like that. For example, let me take an example. If you have a person, athlete running a 100-meter relay, and the fastest runner will arrive first, and then so that person will get the first ranking, and then a second runner will arrive, that will be the second and third and so on. But between number 1 and 2, the first runner that arrived, the second and the third one, there is order, but you cannot subtract also the number, because the time that the first runner arrived and the second runner arrived, the difference will not be equal to the difference between the second and third runner. So maybe the first runner arrived just 1 second before the second runner. But the second runner, the difference between the third runner and the second runner, maybe the third runner arrived 3 seconds after the second runner. So you cannot, it's telling you order, but you cannot subtract. So that's why it is important that you know the difference between the type of measurement, or sometimes we refer it as level of measurement or measurement scale. Okay, now there is a question here. The word scale, is it also refer to variable such as ratio scale? Now, the variable is a characteristics that is a variable is measuring or telling about the characteristic of a respondent, for example. But the scale here is more referring to the level of measurement. The level of measurement or the scale of the measurement is the lowest ranking, or the lowest level is nominal. The next is ordinal, and then the higher order is interval. Then only comes ratio. It is already in hierarchy. Right? Now, is it interchangeable, the word? I think it's safer not to interchange the word, but I know where the question is coming from. The diagram that I took from the source here, it writes you the name of here nominal variable. I think that may confuse some of you, but we are talking about, when we talk about scale, it is telling you about this level, nominal, ordinal, ratio, interval and ratio. Here, when they want to classify the variable, we have categorical variable and also quantitative variable. So categorical variable are only categorized into two types. Either it is nominal or ordinal. But numerical or quantitative variable is classified either interval variable or ratio variable. That is what it is referring actually. Okay, but usually we do not use interchangeably the word scale and variable. I hope that clarifies to the question given here by Mahfuza. Okay, now we are ready to practice.
Prof.
Yeah.
Thank you.
Okay. Now we are ready to practice. If you have your data and you want to do your data, you can also do that. But otherwise, we want to learn how to create this SPSS data file based on this question. We will give the name, and we also define the values for the label that we will use for each of these questions. Okay, to do that, we go to our SPSS. I hope everybody has opened the SPSS. Let me stop sharing or escape here. Okay, if you are currently in this window here, that is okay. You just click File. Everybody has opened the SPSS software?
Yes.
Yes.
Okay, now you can click New Data. When you click File, New Data, it will give you an empty data editor window with the data view here and the variable view. So we will always start with the variable view. Okay. Now go to the questionnaire. I hope you have already obtained the slide, because we need to refer to the questionnaire. I have it on my other computer here. All right, okay. So the first question is about gender. So now this is a questionnaire. So we will get maybe whatever number of respondents that you have here. So it is important if you collect or your data comes from a questionnaire or any other method, it is best that you identify the questionnaire or the person. So the first variable usually for questionnaire, we will put ID. So I will type the variable name as ID. I enter or just tab, automatically it will give you a numeric type with 8 with 2 decimal places, no label, no values, no missing value is none, not defined, and then columns, this is even like that. But the measure here for mine, it does not give you any measure. Okay, so here I will click, double click. Let me go through this again. You have to double click here on the cell, and because ID is just to name the questionnaire, I will choose nominal. Everybody okay? I do not need to put label here for ID. Now the second variable will be for the first question. So I will type here gender, or if you want to put sex also can. You enter, notice here it automatically gives you numeric. So I want to change this one because I know gender is okay, not here, the measure, sorry. So this one I maintain numeric. If you want to type male, female like MF, you will change into string. Where is the string here? Okay. For this one, I will maintain numeric. Okay. Now the label, I do not need to give a label for gender because it's self-explanatory here. Values, I want to define. So you click at a cell, automatically it will pop out a dialog box. Everybody can do that. You click at the cell value, it will pop up this value label dialog box. Now I will tell here that the value 1, I will assign for male. I just enter, or you can click at add. It is more simplest that you just enter. So it will give the definition here. 1 is for male, 2 is for female. You enter value 2, the label you are giving is female, and then add. So because there's only 2 categories, we are done here. If you make any mistake, you can go highlight where the mistake is. For example, if you highlight here, you can either remove, or if you want to change, like here, if you want to change under label, you can write but that it was already correct just now. But if I want to change, you can if you want to represent female as female maybe, then notice that the change is highlighted here, so you can change. But I will maintain here female. Okay, I do not want to change the value because it's already correct. So I do that and then click OK. So what did we do just now? At the value for gender, you double click, it will pop out a dialog box for value label. You type in the value and give label and then click OK. Okay, the measurement I also want to assign is as nominal. Everybody follow?
Yes.
Yes. All right. So now let's go to the next one. You can try to do the next one here. It is on program. Enter program and then give the value. The label also I will stick as program. For label here, I do not want to change. So now I will assign one as, you can tap to go to the label. one as 80,210. 80,210 and enter. 2 as AC120. 3 as CS143. This is wrong, right? I write 80,210 is wrong, so I will highlight this one. I will change. It is actually 80,110. So notice that I do 80,110. Change is highlighted, so I click change. And then I click OK. Everybody following?
Yes.
Okay, let's try the next one. For the next one, I put income. You can use other name if you like. Label, because I need to label this one because this is not the respondent's income, it is the parent's income. So I label the variable as parent's income. For the values, one will refer to less than, I don't know whether this is allowed or not. I will try 1,000. Okay, it allows. 2 as 1,001 to 3,000. 3 as 3,001 to 5,000. Fourth is more than 5,000. Can you click OK? If you want the dollar ringgit Malaysia sign, you can also do that just now. Okay, if you want a dollar sign, you can put RM here. Change. Okay. Okay, when you finish, you can click OK. So that settles it for income. Now the next one, you can give the name whatever you want for that. I will put hours. And this is referring to the number of hours of online classes per week. You don't need value labels for it. Oh, I forgot to write the measurement just now. For program, nominal. For income, you can put scale. Hours also scale. Now, the scale, the word scale in SPSS is not the same like what we have discussed just now, that there are 4 types of scales. So next, you can write the next question is amount spent, amount. So it is referring to amount spent on data plan per month. Per month. Okay. When you enter, it directly give you scale. I do not need to choose when you enter. Now the next one is about what? Okay, this is the Likert scale. There is a shortcut that I'm going to show you later for the labeling of the values. The first one is about monologue. Monologue. You write the whole sentence there as the label. Lecturers are actually dominated is monologue without revealing application. Application of what is being taught. See, when I enter, I tap to the measure, it automatically changes to scale. Next variable is about textual. I give the name textual. So the label is the information provided in lecture is very much textual and can be retrieved easily. So textbook. I hope you have the steps now. This is just to give the idea how to key in. Okay, the next one is what? Curiosity. Curiosity. Lecturers usually fail to generate curiosity and further motivation to know about the topic. Everybody okay or not?
Yes.
Okay, so now I hope everyone has the idea. Now notice that I haven't defined the values for the Likert scale question. Now I'm going to do only for one. Then I can copy and paste. One is for strongly disagree. And then two for disagree. Oh, sorry. Disagree. 3 for neutral. 4 agree. 5 is for strongly agree. So you do this like what we did just now. And then we click OK. Now we can go to the cell here, the value for the other two questions, textual and curiosity. I'm just going to copy this one. Okay. What I'm going to do is, instead of defining for all the other questions here, we have two similar value labels. So I'm going to copy, highlight the cell, you copy, and then you can paste. So you paste to the two cells. So that is the shortcut that we can do for questionnaire. If you have the same labels for the values for each of the question. Okay, so that is defining the variable. Notice if you have tried giving the name just now with a space or have repeated any variable name, SPSS will not allow. If you have, if you ask maybe students comments, if you like for example question 10, you ask comments and you want them to write a short answer. So maybe you want to change the column here, giving to a maximum of 64 characters. You can change this number here, the columns. If you want to give it a higher number, it will increase to a higher number. But for now, it is sufficient that we have 8 by default. Okay. The missing value here, if you want to define the missing value here, you can do just now, like what we have shown in the introduction. You just highlight under missing. If, for example, for question income, you want, if there is a non-response and you want to identify for some reason why people do not want to answer, you can define here. You can also have a range of values. Okay, but for ours now it is clear cut, so we will skip that. Now you can go to the data view. Go to the next slide. I hope you have the data here. You can key in the data. You key in the data in the table for practice example 1, part 2. For ID, usually we just go by number here. We have only 7, so I stop there. Now, notice that the ID number that I have put here is consistent with the row, the first row in the spreadsheet. Some people do not want to give ID number for respondents or items. They want to depend on the number here. I do not advise that because there might be reasons that you delete data or you add a new case, it will change. If you add a new data here or you delete a case, then the number here will be referring to a different case. So I would advise that you always include the ID number. One is for the purpose of detecting which case. If you have found a mistake, you can go back to the questionnaire according to the ID number that you put on the paper. It should be similar to the one that you entered here. Okay, gender. Now, if there is a mistake in the gender or whatever that I have given you, I have purposely put one mistake there, but we want to use that later. So just enter the information. So this is quite fast. Program. If you cannot see your slide, you can follow what I have written here, but it is quite small. Amount is 50, 35, 38, 35, 50, and 200. I miss one data. What did I miss? 38. I missed 38. Okay, I miss. I can cut and paste here for the one that I have typed. Cut and then paste. Okay, the one that I missed was 38. And then we have 4, 5, 2, 4, 2, 1, 3. For textual, we have 4, 4, 2, 3, 2, 2, 4. Curiosity or motivation, whatever definition that you use. I did not refer to this table when I typed just now. All right, so I finished typing the data. How's everyone?
Okay, but need some time to type it in.
Okay, no problem. We will wait. I think it is quite a nice time. We will have a break in 5 minutes. So we will continue using this file and also the employee data file afterwards in our example. Any questions so far?
All right, if there is no question, thank you, Dr. Professor Johanna. Maybe we can take a 5 minutes break for you to take a breather.
Okay.
Thank you.
So before we do that, let me go through. After you have typed, remember we look at the command for save just now. You either type file save as, or you can click the diskette icon here. So I'm going to do it the long way. File save as. Okay, give a name for the data. Let's say this one is what? Example 1. Okay. You put the name of the file and then you save. Alright, save. Once you save, notice at the left upper corner of the spreadsheet, the name of the file is given, example 1. Right, okay. I think it is good time for us to stop. If you have any question at the beginning of the session after the break, you can ask. All right. Thank you for your attention.
All right, okay, thank you, Prof. Ladies and gentlemen, we will continue in 5 minutes. All right, ladies and gentlemen, PM Rahana, shall we continue with the session?
All right. Okay, I hope everybody has freshened up. There is a request here for the questionnaire. I'm not in the group, so in the WhatsApp group, so can Encik Azlan post it to the WhatsApp group. And there are questions here that I did not look at just now. So we're going to address the first one that is latest, which is about the income. I think I forgot to define just now. That makes some discussion in the chat. All right, now the numbers one representing 1,000 ringgit and two for between 1,001 and 3,000 and so on. This one, I forgot to change the measurement here. Now, there are discussion in the chat there. Some say it is nominal. There are some says ordinal. Now, notice that there is order here. Number 2 is telling you that the amount of money is more than category 1. Number 3, the amount of money or the income is more than in category 2. So it is not nominal. Okay. So if it's not nominal, then the next higher level will be ordinal. There is order here. Now, can we put this as interval? No, we cannot put this as interval because the value here, 1 and 2, notice that 1 is below 1,000. But for 2, it is between 1,001 and 3,000. It is referring to a difference of 2,000. And here also difference of 2,000. Here is more than 2,000, the difference. So we cannot categorize this as interval, but we can put it as ordinal because there is order. So I need to change this one, the scale here, I forgot. By default, if you enter, you do the tab, it will automatically give scale. So I will change this one to ordinal. Right? And the next question is from, let me check just now, it is about if you have multiple questions. Let me check the chat here just now from, okay. If you, from Aini, we have, if you have people needing to answer more than one answer. If you have, what ages? What are the ages of your children? You may take more than one answer. So we will treat for each of the answer as one variable. Okay, I will just add this one even though it is not relevant to our case here. I will put here as age. Okay, I define the variable age for preschool. So maybe I put age preschool. So this one is labeled as preschool, age between birth to 6 years. Oh no, I don't want to do that. Okay, that's okay. But now what is the value, the choice of answer? You ask the respondent to take. I will put 1 as yes, 0 as no. Typing error here, no. That means that the respondent do not answer that, or rather they don't have children. Okay, the next one is primary. And I will put the label here similar, like what we have just now. 0 if there is no tick, 1 if there is a tick. So I copy paste this one. You copy and then you paste. Oh, I need to do it straight away. Control B. Okay. So you do that for each of the choices, you will have a yes or no answer. All right, Aini. So before we continue, any
Assalamualaikum
yes,
Prof.
Salam.
Saya nak tanya dekat variable view tu, boleh tak tengok kat variable view tu balik?
Okay.
Okey, dekat measurement tu kan kita ada apa 4 kan, nominal, ordinal, interval, ratio. What if kalau kita sepatutnya benda tu kita letak ordinal, kita tersalah letak nominal. Saat kita tak perasan sampailah kita habis buat semua. Adakah dia akan affect kita punya the quality of kita punya data tu nanti?
Dia punya if you restrict it to nominal, that means some calculation will not be allowed. For example, income, if you let's say hours here, you put as nominal. That means for hours, if you want to calculate the mean, then I think it will block for you. But if you and then the choices of the statistical analysis also will be affected. But if you maintain it as scale, let me show you here. We will cover that later, but never mind, I will show you now. Let me say gender we put as scale.
Yes.
Okay, now when I find the mean, we will go through this later also, yeah? Okay, but this one, let's say gender. Now I want to find the mean. It will give you output, it will give you a mean of 1.4286. That means SPSS will calculate for you even though there's no meaning. So that's why you as the user must be very careful to know that the data that you are entering is ordinal or nominal. Now let us try here. I'm not sure whether it will allow you or not. If we change it back to the, where is the data just now? Sample 1. Let us change it back to nominal here. Let's see what does it allow us to calculate or not. See, it will still calculate here. It will calculate. It will still calculate, but you cannot. You must know on your own that it is not actually making sense. Let me try and change this one to string. Okay. Let me change the answer here. The data view here. Let me say I type male. I need to change the scale first. Nominal, okay. I change it to string, okay. Let us try string here. Some value, okay. When I change this to string, let me say this one is F, M, F, M, M, F, F, oh, M, never mind. Let us try, will allow or not? It should not allow, but let's see. So see, gender, it does not give you.
They don't give any.
Actually, in conclusion for that problem there, if you put it as whatever scale, actually it will remind you what to use. Where is it? Here. Okay, example here. Now, if you notice that what I did just now for version 25, I don't know how it behaves in version, the latest now is 28. When I change the type into string, it will not allow you to calculate for nominal. But if we maintain it as numeric just now here,
it still allow.
It will allow, but it has no meaning.
Has no meaning.
So this is about mean, descriptive measures only. If it is for the test, I don't know whether it will block or not. Notice now
Okay.
when I define it as string and then I change into numeric number here, the data is lost. So
Okay.
we need to put it
Be
back, but I have the data file again. I do not save this one, so I will not have problem. I will just
Okay,
not
thank
save
you, Prof.
this one. Okay. Any other question?
Prof, saya nak tanya, okay, for example kata kalau bahagian untuk variable hours, kata kalau hours for online classes, saya nak limit students not allowed to get the value more than 40 hours. Boleh tak kita set dekat kita punya setting kat mana-mana? Which means a user can only allow to put the value around 0 to 400, 40 sahaja. More than 40 tak nak, kita tak nak.
Yang tu dalam questionnaire kan. Maksudnya bila kita key in, kita dah key in apa yang ada lah. Maknanya you block masa dia jawab dekat questionnaire lah.
Okay. Maksudnya
But
dekat sini tak boleh lah kalau kita nak control dari segi error key in data tu.
No, the key in of the data actually depends on what the respondent answers. If you have the data, let's say a student answer 400, but you do not want that data, then we need to see what is the data about, and maybe is it an outlier or is it an error. So we had to check that. Afterwards, I will also cover how to detect outliers and how to detect the error. Right? But you should, the data entering is just entering the data that is already answered or that you have already measured from the instrument. Okay, so now let's look at what is the next slide about. Okay, this one example we finished. Now we want to learn how to import from Excel. Now many of us are quite familiar with Excel, so there are tendency that people will use Excel to key in data, or if you have some data maybe given in the internet is already in Excel, you might want to open and save that one. So what you need to do is now can everybody, if you check in your data file, you should have a file in Excel. I think I label it as diet. Okay, let's go to SPSS. We will click File, Open. We want to open data. It will give you an open data dialog box. And then you change the type of data to Excel here, if it is in Excel, or you have other types of data here also, SAS, Stata, and so on. So I've saved it in file name diet. So I click that one and then open. When you do that, mana perginya? Lambat. Alright, so now it pops out another dialog box. Usually I will just take like this. We want to read the variable names from the first row of the data. If the data is actually labeled, the first row is labeled by the variable name. If it's all data, no variable name, you must untick this one. Okay, so I just click OK here. So you are opening data in the SPSS version, but let us click the variable view. Here, if you notice, did you get this one also?
Yes.
Okay, so now you need to check the scale here, it is okay. This is similar to what the actual value is, but no label is given. The original data has label. The values are also not labeled, right? So you need to enter this information. But now whatever data you have in the Excel is now in SPSS with a slight modification that you need to add on is to label the variable, gives value labels if needed, and then you check the measure, and then you can save as, give a file name lah. I will not give a name because I have already saved it in diet study with the labeling all done. Right, so it's quite simple to save data from other sources. Okay, so the next slide is we want to look at example 2. So this one I settled just now. Did you try to open the file diet in Excel and save it in data file, SPSS data file?
Yes, bro.
Alright,
Yes.
so it's quite simple, okay? So now the break is done already just now. So let's look at the third part of the session today. We are talking about data screening. So this is some technical skill that you need here. We're going to look at how to detect errors, and we want to search or find the errors and edit accordingly. You can also sort variable. You can select cases. You can also split file and then save if you want. You can merge two files together. You can also aggregate variables to a new file. You can do transformation where we can compute values. And then we will also talk about handling missing values and also handling outliers. All right. For this example, we're going to use the employee data. All right. We can detect errors through two methods. The first method is through the frequency table. You analyze descriptive and then press frequency. If you have not opened the data yet, can you open the one that we typed just now, example 1? Let me show you how to switch from window to window. Now, if you are already in employee data file, you click here under window. At the menu bar, you open the, I've closed it, so I need to open it. If you have not closed it, you can just move from output to whatever data that you have. I still have the employee data, but I do not have the example data. So I'm going to open it now. Data. Example 1. Okay, example 1 here, I've not corrected the income here as ordinal. All right, so now we will run through this one. Through the frequency table. One is you do by clicking analyze, descriptive statistics, and then use frequency. Okay. A dialog box appears. We can put frequency for all, but I'm going to put for let me take program and program. I take program first. Okay. I click program and then I click OK. Okay, if you look at the output, can you see the output here that I'm highlighting here? Notice that we have whatever you have typed as the label will appear here. We have two AT110 student, two AC120 student, and two CS143 student, and I have one for number 4. So we don't have a category for 4. So that means that is a mistake there. There's an error. So this is one way of you to find the error is just to run the frequency table and you can go through the output. You can see if there is a wrong number there, then you can detect it. Let me do one more here. We are in the example 1. Okay, let me make a mistake. I will make a mistake here. Let us put for number of hours. Let's say I put 200 here. Okay. I will run same thing, descriptive, frequency, but now I want, you can either put the arrow back here or you can reset. You can reset, it will change. So I take the number of hours just now and run. So you will notice there, it will list all the number of hours. If you found that from the table there is some suspicious value, is it logic that the student have 200 hours per week? That means 40 hours a day, which is not correct, right? This is one way of detecting. Another way, the second slide after that, is you run the frequency statistics here again. You click analyze, descriptive, frequency. Under statistics here, I will maintain the same variable here, number of hours. I click at statistics. You highlight maximum and minimum. This is one way to detect error. You highlight minimum, maximum in statistics. You click continue. Click OK. Let me repeat. You click analyze, descriptive, frequency, same like the command that we did earlier. And then you move the variable that you want to check, and the new command here, you press or click statistics and highlight the minimum and maximum value and continue, and then click OK. Now, when you request that value, notice here, it gives you a minimum of 8, maximum of 200. Now, if this is not logical, then it is an error. If you know that the range is between 200 per week, that means for 5 days, it's 40 hours per day, which is not logical. So you know that is an error, right? So that is one way of detecting error. Now, how to find the error, the next slide. Now we have to switch window to window. So if you have a hard copy or you have you see the slide in another computer like I'm doing now. Now we want to search for the error. Now I'm highlighting this one, hours, but this is not interesting because we know that the value is 200. Let me switch to another window. I hope you're okay.
Prof.
Yeah.
Sorry to disturb you. I don't have the output of missing. Can I put back to the data or what?
Output for missing. What do you mean?
I don't have the missing value. Adakah saya tak letak sebelum itu?
Oh, you have your output have a missing value.
Don't have.
You don't have a missing value.
Ah.
You should not have missing value for this data set because we entered everything just now. But the only problem maybe you have differ from what I'm having now on the screen because I just changed the first data to 200.
Yes, I also change it to 200.
Okay.
But the output says missing 0.
Oh, let me do it again. What happened to yours? Let me see. Did you
Back
do
to
this one?
example 1.
This is example 1. Analyze. You click descriptive statistic frequency. That's okay, right? Now, did you check for number of hours or you check for program just now?
Hours.
Okay, for number of hours, you click statistic. Did you click minimum and maximum? Under statistics?
Okay.
Okay, then continue.
Under statistic.
Under statistics, you click statistics. You click under the dispersion here, minimum, maximum.
Statistics under analyze, right? Statistic frequencies.
I repeat again. You click analyze, descriptive statistics, and then frequency.
Frequencies. Right.
And then you get the dialog box.
Hours.
You put the variable number of hours into the second space here, and then click statistics at the right.
Right.
Okay. Then make sure you highlight the minimum and maximum value and continue.
All right.
Then click OK. Is this display frequency table highlighted here?
Yeah.
Okay.
Minimum and maximum.
Okay.
But doesn't have value of missing 0.
Missing. I have missing. What is this number of hours?
Yeah,
I have
that's a
missing one.
problem.
Oh, I know. That is correct. Just now, remember, I think I make changes. Let me check the data.
Yeah.
I think I make a change just now. Example 1, did I make change? Oh, okay. If you can see here, I have mistakenly put a missing value for all the variables here. Notice that there are dots here.
Oh.
That means this I have entered this one just now.
Should
without
I
entering
follow?
any data. So I'm deleting it now. I highlight the row.
All right.
I delete. Now the data set is okay. I might have entered something just now and forgot about it.
All right.
Now if I analyze, you will notice that we will have no missing values
missing.
because everything is typed. Okay?
Right.
All right. So now where were we? We have shown the two types of ways you want to detect the error. Now to make it more interesting, I'm going to go to employee data. Right? Okay, this is the data view. I'm changing one of the values here for education level here. I'm going to put it 150 here. Okay, now if I run the frequency statistics, I will notice that there is an error. The education level number of years become 150, which is not logical. Now, if we want to find it, okay, we can now highlight the variable. What I'm doing now, I highlight. There is two ways of doing this one. Either you use the binoculars here to find, or if you use under data, you will find. Where is it? Find, is it here? Oh no, it's under view, not view. Edit, sorry. Edit, the binoculars is here, find. Everybody okay? You click edit, you click find. You know the error is 150, you type 150. You click find next. It will go to the case where the error is. Can everyone see the highlighted number here, 150, because I'm finding 150. So you have detected that the error comes from respondent ID 23. So this is finding the error. Now, if you know the value, you can change it back. Like just now, I know this is 15, so I'm changing it back. I can write 15 there, or you can use the command replace here. Okay.
Prof, sorry, can you show it again? Because I was trying to opening the employee data, then I lost it a bit.
All right. Okay. Let me repeat this one. Now, if you want to find the error, you know that from the frequency output just now, that 150 seems strange. It's not logical. So when you want to find, you click edit. There are two ways. Either you use the toolbar here, find, or you click edit and then find. What do you want to find? The value 150 lah. Where is it? So I put 150 there and then I click find. It will highlight to 150. Okay, let's say another value also 150 here, which is wrong. I click find next, it will highlight to the next case. So we have to not found. Okay, the string. Is this string? No, 150. Did I enter it wrongly? 150. Okay. It highlights the new one that I changed it now, 33. Respondent number 33, 150. So if I know the value, the correct one, I will change it back lah. To change. Okay. You okay?
Yeah, okay, thank you.
And then the next slide is about sorting variable. Sorting variable, okay, we are in the employee data set again. Alright, so now what we do is we click data to sort variable. If for any reason you want to sort all the those that have less number of experience in the earlier part, if you want to sort, you click data, you find sort cases. Where is it? Sort cases here. Data, sort cases. What do you want to sort? Maybe educational level, okay? So I put educational level here, I highlight it, put it to the sort by. Okay? And then you can request it ascending or descending, and if you want to save it with the sorted data also can. We have not changed anything, but we are just going to sort it, okay? If you do not want to save the file, for our case, we just want to show you. So I click OK. Now notice that our data here are sorted according to the, because I by default it is in ascending order. So here 8, 8, 8, notice all the who have lesser number of educational level, the number of years here is the lesser value first. Now, how do you know that it is changed? Notice that the ID now is changed. See, the first one 4, 12, 36, 44. So this is why the reason that I say you should put an ID for your respondent, so that now number 4 is not consistent with number 1 in the SPSS here. So this is for sorting variable. If you have any reason you need the sorting. All right. Now the next case, If you want to analyze the selecting cases, we are at the next slide. Let me look at the checkbox. Okay. Now, to select cases, you go to data, select cases, click select cases, it will pop out a dialog box. Now, what you do next is you find here if condition is satisfied. Okay, click if. Now let's say we want people educational level less than 8 years, less than or equal to 8 years. Where is less than or equal here? Less than or equal to 8. And then we also want the current salary to be more than, let's say, 30,000. So I click here. I did not enter it. Current salary, make sure you put the variable there. Salary greater than 30,000. Whatever cases that you want to select, if you want to select gender, for example, for male only, you highlight gender, put it to the dialog box here, and then gender equals to 1. Or gender equals to F for this case, okay? So now I continue. Everybody following? You click data, you click select cases, and now I want to only analyze those people with less than or equal to 8 years of educational level, and but their salary is 30,000 and more. Or just more than 30,000. You can choose here. If you want just more, here. If you want more than or equals to, also can. So then you click continue. And then click OK. If you want to filter out, you just filter. If you want to delete altogether, you can highlight here. But usually I will not delete everything. I will just filter out. Okay, click OK. When you do that, you go to your data set. Notice there are slash here. Those who are selected are those without the slashes. So that means respondent number 36, if you have ordered it just now, if we remember, we have sorted it just now according to a number of years of education. Notice that respondent number 36, there is no slash. These cases 3, 10, 14, 15 and so on, those unslashes are the ones that are included in our cases. So if you want to proceed and analyze only for these particular cases, then you can go ahead and do it now. But don't forget, after you have done that, if you want to do all the analysis for all other respondents as well, you must click back to data, select cases, and choose here all cases. Okay, I choose all cases here, and then OK. Notice that now the slashes are not here anymore. Okay, so that is selecting cases. The next slide is splitting data files. If you want to split the data file, I need to go faster now, but never mind. We go to the next one, splitting file, okay? Splitting file, you go to data, you go to select cases. Where's select cases? Okay, you must, let's say you want to have data for those who are categorized the minority, there is a variable in the file, minority classification. So I want to do that. So if condition satisfied here, I choose if minority classification here, I need to reset or just delete it back, never mind. Put the minority classification to the right here equals to 0. Now I know that the label is 0, 1 and a missing value. So I want those that are not classified as minority. So I put minority equals to 0 and then click continue and then click OK. Now if you want to delete the cases, there is a deleted cases here, otherwise just maintain it. Okay, so now I want to delete. I want to delete because I just want those cases with the minority people not classified as minority cases here. So I click OK. It's almost the same like what we did just now, but that one just now we do not split the file. Now, if you do that, notice at the data file, here we have the minority only for 0. Notice here the data set. If you look, all those that are with label 1 for minority is not there anymore. See, everything is 0. So the sample size is lesser. And then I click save. If you want to save, then file, save. Okay, save as. If you want to save it, if not, you do not need to do that. Right, for now, I will not do that. I will just close without saving it. Any questions so far about splitting? It is like select cases, but under the command, you instead of filtering unselected cases, you delete selected cases. So when you do that, you are splitting the file into a new category file. Okay, you can also merge file. You can also merge file. Let me go back to let me close this one. I don't want to change this one. Do you want drawing? No. Okay, so now I will open back the data. Okay, this is the original data. To merge file, right, you click data. There is a command there, merge file. Where is it? Here, merge file. Add cases. If you have 2 files, you want to merge them together, you add cases. Now, let me reset, open data set. I want to browse. I want to browse a new file. You should also have the file. I've given employee data 1A and 1B. This is just, I split the file into 2, but now I want to demonstrate to merge. I put employee data 1A. Okay, you add cases, you browse, find employee data 1A and then open, click open. Okay, and then you continue. When you click continue, notice here if you have unpaired variables, you can define here. Okay, but our data is the one that I have given you there is actually the same file I split and then just to demonstrate to you. But if for any reason you have a different variable which is unpaired, it will automatically shows here also. Okay, and then you click OK. When you click OK, what you get actually, you have to go in back and look at the data. You have now more cases lah, of course, because I have added data. So now we have 844 cases. Okay, but I'm not going to save this one. If you need, if you have merged the two files, you can save it as another file name. So I'm going to close this file without saving. Okay, so that is merging file. You can aggregate file also, aggregate variable. We have now, I'm looking at the time, this is, now it's already 10, almost 11. I think we have, it's okay, I will go through the aggregating variable, okay? So look at the data file here. You click data. And then there is a command here, aggregate. Click aggregate. Oh, I need to open the file first. We have to open the employee data. Okay, now I repeat, we click data. We choose aggregate. Everybody okay? Now we want to choose which data do you want to aggregate somehow. Okay, so what I'm going to do is I will take, we want to aggregate what data? Employment category. Employment category, we put under the break variable. We want to combine or aggregate for current salary. Okay, so now you click on current salary. Click the arrow. Now notice it automatically finds you the mean. If you want another function, you click here, function. If you want to sum the values, you can click sum. Continue. Now notice that it calculates for you the summary sum. Okay, let me do one more. I take current salary, but I want to take the mean. By default, it is set at the mean. Okay, so I have now salary, the mean for the salary and also the sum for the salary. Let me do one more for the beginning salary. I want the mean and also I want the sum. So for the sum, by default, it comes out as mean. I want to change the function. I click function. I click sum under summary statistic. And then I continue. Everybody okay?
Okay, Prof.
Click continue and then click OK. But I need to give, I want a new data file. So before I click OK, I need to remember to put the new data file name. So this one, let me put aggregate employee, or rather aggregate salary. Okay, you need you put the new data file, and then we want to sort If you want to sort the data file before aggregating, also you can. And then okay. The file of the not valid. The data file name is not valid. Let me change aggregate. Is it because of the space? Aggregate salary. Okay. The data file name just now I put aggregate salary. It refuses to accept. When I put underscore for aggregate salary, and then it accepts. So what does, let us look, what does the data set look like? You go find the aggregate salary here. Click the window, we can move to that. So notice here we have, because I've selected only for those employees for the employment category now. Just now we have by job category for job 1 category, 2 and 3. They aggregate the values for the beginning salary and current salary. So you have a data set where you have aggregated the values for the variable that you have assigned. Okay, later maybe you can try to choose different select cases and then find the same value. This depends on what actually you want to do. Maybe you need.
Sorry, Prof, to interrupt you. I never use this aggregate. Okay, actually why we use this aggregate, the function is to combine data one from one data set with another data set. That's why we aggregate. Is it the purpose?
No. This one is if there is for any reason you need the total values according to certain criteria. Like this one, the criteria we have is for job category. We have 3 different job categories. So I want to find, I want to know what is the mean of those employee in the job category 1, and also the total amount of salary for all of them. So that's why I use aggregate. If it's not needed, then you do not need to do that.
Because
this is just maybe some there is a need for some of you who in your analysis you require not the individual value, but you want to analyze the sum of the values, for example, and maybe you want to combine with another data set that you have found from another company, for example, and use that. Maybe one version is aggregated the value according to either mean and sum, but another data set you have individual data. So what you can do is for the individual data, you aggregate them first according to the same as the other set of data you get from another company, and then you can merge them together. Maybe that might be a reason for you to use that.
Okay, thank you, Prof.
Okay, the next one I want to demonstrate is the transformation. Let us look at the slide. Okay, we have done the merging, aggregate, and now the transformation part. For transformation, you can compute values, or you can recode the variable that you have. For example, just now, if we look at our example data, notice for the 3 questions on the lecturing, either textual or curiosity just now, if you notice that the statement, is it negatively worded or positively worded? Let me go back to the slide. Here, okay. Lecturers usually fail to generate curiosity. Now, if you answer one, you disagree, that means for the lecturer, is that good or bad? For the third question
Good.
here, it's good, right?
Yes.
If a respondent put number 1, disagree that the lecturer usually fail, that means the lecturer do not fail lah. So these statements here are actually all negatively worded. So giving a number 1 in our normal or daily life, number 1 is lesser than number 5. So we would like to see that number 5 which represent better. So if we want to do that, we need to recode these categories here. Or just now we also mentioned that these individual questions are ordinal scale. But if you want to make analysis, you need to combine these 3 questions and then have an interval scale. The summation of these 3 responses or the mean of these 3 responses will be interval scale. So you need to do recoding to make it to become 5 representing good and 1 is lesser than 5. And you need to combine the 3 values either by summation or finding the average so that you have the scale to be in interval or ratio scale, and then you can do analysis that is allowed for mean and interval type of data lah, interval or ratio scale type of data. Okay, let's look at the example here so that we can understand how to do it. Okay, for compute, the slide here, can everyone see the slide or not without me showing? I want to go to our file here on the employee data. The slide, I'm showing you a new calculation. I click transform. We find compute. Is that there? Compute here, is it not here? Data. Edit.
Transform for. It should
Transform.
be
Oh, I missed. Oh, sorry.
Yes, transform.
Sorry, letih lah tu.
Tak apa.
Okay, transform. So there is 2 command here that we want to use for today. So the first one is for compute variable. So I'm computing here, I click compute. Target variable, what I want to do, I want to define a new variable where we want to find the difference between the current salary and the beginning salary. So I give the variable name as difference. If you want to label and give a type for it, you can click here, but now I'm going to skip here. The numeric expression is I want to find the difference, so we take current salary, use the arrow to move it to the right, and then you subtract the beginning salary, move it to the right, and then you click OK. Afterwards, you will try with the example data, we want to find the average. All right, so this one we click OK. Now, if you go and see at our data view for employee data, see that is a new variable here, difference. So you can do the computation here. At the variable view, under difference, there is no label because I did not type. When we do the computing just now, you can type there or you can type here. right? So that is the compute part. Any question? Okay, now we want to recode. Before you try, I'm going to show you for this one here. For the employee data, let us look at the data here. Let's say we want to define a new job category, right? So now you click transform. What we are doing? We are doing a recoding. You have two choices here. Either you recode into same variable or you recode into different variable. I do not advise people to do recode into same variable just because you will lose the original value. So I usually will do a recode into different variable. Okay, now the variable here that we want to do is the job time. Where is the job? Job category. Oh, month since hire. Month since hire, I move to the right as the input variable. The output variable, I want to define job time category. If you want to put label, you can job time category. And then you click change. What did we do just now? First, you move the variable that you want to change or recode into the right. And then you give a name for the output variable without space. And then you can label the variable. And then you must click change. Now, when you do that, notice that it is labeled here that the job time will be changed into job or recode into job time category. After that, you click all and new values. Okay, what did we do? We click all and new values. Now we define here. We have to know about the data there, what is the category there. So I forgot what the data was. We can define range. Okay, range, the data here, I think the education just now was minimum 8. But we do not look at the, let me cancel this first, yeah. I cancel this one. Let us look at the data. Frequency for job time. Month since hire. Okay, if you look at the output, you have data from lowest 63 until 98. All right, so now we can do the transform here. Transform and then recode into different variable. What do we want to change? The month since hire into job time category. Table job time category. And then change. Then click all any values. Okay, I'm going to show you range. Afterwards, you're going to practice for the Likert scale, but now I'm showing you for scale from 60 to 69. Value 1. Okay. 1 is you click add. So now notice that 60 to 69 becomes 1, and then we do another one, 70 to 79, number 2, add 80 to 89. Everybody following?
Yes, Prof.
Number 3, you add 90 to ours 94, 90 to 99, number 4. Okay. Now, if you want to change into string, you can also change here. Otherwise, we maintain here. We are defining or recoding it into a new category. Okay, continue. And then click OK. Right, click OK. So now under the data file, if you look at the end here, we have a new job category. See, because we have sorted it just now, it is in the sorting form. Right? And then if you want to define what the category means, you go onto the variable view. You can define the values here. One refer to what? You can define one. I've done it there. I forgot what the label was I used. One for
Learning employee.
then learning employee. Add two for fitting in employee. Oh, I did not move. Add fitting in employee. 3 for expert employee. 4 for dedicated employee. I just created the name. Yes, okay. Dedicated employee, okay. So when you run the frequency by clicking analyze descriptive frequency and we move the variable that we just defined, job category, you click OK. Notice it will give you the output accordingly. Now the reason you might do this if you want to do chi-square and you need some categorization for the variables. Okay, if you cannot do parametric test, then you might go to non-parametric. So there might be a reason why you need to do this kind of decoding. Okay, now can you now go to our example? Practice example 3. Let me show you the slide. Okay, this one I ask you to use for our employee data. This is another data file set. So I think to shorten our time, can you go to the example data that you have typed in? Everybody finish, complete or not that data file?
Yes.
Okay, if you have completed that one, that means you can do that. Go to the example data. We want to recode first of all. Question on the Likert scale one. Okay, this one. Now we want to recode this one. So that 5 means better than 1. Alright. So go to the example data. Okay, what do? We click transform. We recode into, I usually like to recode into different variable, as I say, because I don't want to lose the original. Okay, so now the 3 question here, we can do 3 straight away if not mistaken, because the values are the same. So monologue, I will put monologue mono new for our new output variable. Okay, then click change. I will not label for now. Okay, now you move to the next variable, which is on textual. The name, let us put textual new. Or you can put recoded also can. Change. And then take the third variable, change it to curiosity new. Change. Everybody okay?
Yes, Prof.
Okay, now you click all and new values. And then what we want to do is we want to assign number 1 to be number 5. We take the opposite. Okay, just now the label was 1, 2, 3, 4, 5 because it's negatively worded. We want to change it the opposite way. 1 becomes 5. 2 becomes 4. 3 becomes 3. I'm doing all of it. 3 becomes 3. 4 becomes 2. 5 becomes 1. The new value. Right? And then add. And then click continue. Okay. Click continue. Click OK. Now notice that we have new variables, but it is assigned as nominal here. So I want to change that. Now actually it is ordinal, right? So but I want to put it scale because I want to change it later. Scale. Alright. So now we want to do again the second transform. You compute. We want to find average for the 3 questions. Let's say the 3 question is measuring one attribute. What attribute can it be? Delivery. Okay, delivery. Okay, so lecturer's delivery. So we take transform, we take compute, target variable, let's say delivery. So I label it as lecturer's delivery style. Numeric, I click continue. Okay. If you don't do it here, you can do it in the variable view. The numeric expression, there is 2 choice here. I can add one by one because that's not too many here. So I'm going to add one by one, put the parentheses. You move the mono, new, add the textual new, add the curiosity new, and divide by 2. Not 2, sorry, 3. Because why 3? Because we want to find mean. We are calculating delivery based on 3 questions. We divide into 3. Then click OK. When you do that, what happens? If you look at the data, this is the example data just now, right? Example 1. Okay. So notice that we have computed a new variable named delivery. Notice now the value is not 1, 2, 3, 4, 5. It is 2, 1.33, 4.33, and so on. What's the reason here? Because we have found the mean. That's the reason why even though that the variable monologue, textual and curiosity was actually ordinal scale, now it becomes interval scale. Any questions so far? Everybody is tired.
Seems to be clear, Prof. We can continue, I guess.
Okay, so now we want to look at the next slide on, I'm trying to look at the chat at the same time. Okay, now let's go to the next slide here. What was it? It is about handling, we are going to move to, okay, missing data. Now, missing data, actually for missing data, there's no one way is the best method. The best method is actually if you can avoid the problem by planning your study very well and make sure that you collect the data carefully. That's the best method. Now, if there are still missing data, you can recover the values if possible. That means if you have detected a missing value in the output and you check the respondent's number, if you can contact back the respondent, you can go ahead and recover. Otherwise, you cannot do that lah. Okay, if you can recover, you recover. That's the best method. The next best method after we have designed and planned the study very well. Now, the next category of method is actually deletion. You delete the data. Now, when you want to delete the data, actually you will lose information, and maybe because of that, the sample size will get lesser. Okay. Now, in deletion method, either you do it listwise or pairwise. Now, for deletion, if you do listwise, for example, in our example here, the missing data here is written as not NaN here. Okay, here is the missing data NaN. So if you do it listwise, you will delete the first three cases. So that means you are left with one case here. So when you delete, you will get lesser data. Pairwise deletion means it is used when you are doing a bivariate analysis where you have independent and dependent variable. For example, if for X value is missing, let's say here our variable here is quite a few. Let's say our X is mileage, our Y is price, for example. When we delete pairwise, that means if mileage here is missing for Ford and Toyota, automatically it will not analyze for the case for prices where prices here 20,000 and 30,000, even though available in the analysis, it will do pairwise deletion. It will not be analyzed. That means you will analyze based on Chevrolet and Chrysler only. Pairwise deletion. So what's the difference between the listwise? The listwise means you delete altogether the Chevrolet, Ford and Toyota. Gone. Pairwise, they only do not analyze for the particular analysis for mileage and price for Ford and Toyota. Another deletion might be dropping the variable altogether. This is done when you have 60% or more of the observation is missing. If in our case here, if we want to look at mileage here, this is only 50%. So you will not decide to drop the mileage. But if let's say 3 of the values here is missing, we have Chrysler also missing, That means it's 75% already, so you will delete mileage. But again, if you do that, you will lose the variable that you might need for the study. So that is always problem when you do deletion. Okay, but the most common type of deletion is for list wise. Okay, the other method is you imputate. Imputate means you replace it with another new value. The first method here is educated guessing. That means if a respondent, for example, answer all the question for agree 4, 4, 4, 4, 4. So educated guessing means you replace the missing value with 4. Right? That is educated guessing. Average imputation means you replace with a variable mean. For example, for the variable like what was the variable just now? Like prices. For prices, you will calculate for, let's say we have 4 data, but 3 is available, 1 missing. Okay. Here for price here, this is only can be done for quantitative data. For me, let's say Chevrolet price is not available here, missing. So what you will do is based on the other respondents or other values here, 100,000, 30,000, 20,000, you add them together, divide by 3, and you will replace for price of Chevrolet. Okay, that is mean imputation or average imputation. Or another method is you might want to replace with a median or mode imputation. Median means if you just now for Likert scale, we have 1, 2, 3 until 5, the median is 3. So those missing value, you just put 3. The mode imputation is like almost like the educated guessing just now. If you have a majority of the answers, the respondent put 4, then you would put 4. Now you can do regression substitution or time series specific method. That means last observation is carried forward. That means if you do not, you have data for 2016, 2017 missing. So 2016 data, you put also the same value for 2017. Okay.
Doctor, how do you know which one to choose?
Now again, as I said just now, there is no one best method, and for a particular study, you should know your data well, so you will decide accordingly lah. So because in doing deletion, you will lose data, and sometimes it's not always possible that you recover back the data. So you have to decide accordingly, according to theory also. So it's quite difficult to handle missing data. There is another method which we call group mean, but I personally don't see it as being applicable to many cases, so I did not put. There are other advanced method like using maximum likelihood and so on, but I do not discuss here because I think this is introduction, so we cannot discuss that here. But you can search for your particular area, maybe if it is medical in nature or whatnot, you might go and see the argument that is done for handling missing data for specific cases. But there's no one best method. For questionnaire, I personally use this one, putting the midpoint and also the educated guessing for questionnaire. But that is not always possible. For Likert scale, maybe. But in doing so, when you imputate, sometimes you are introducing bias also. So there are a lot of discussion on this, handling of missing data and what is best to do. Try to avoid the problem. But if you have to do, then maybe if without knowing the detail of your study, I might advise you do the average imputation here, find the average. But I'm afraid to say that also because it depends on what your data is, the nature. Because for example, if you have, let's say your data is about what? Student performance maybe in a test. And you mix different programs, student from different program background, and you know that their entry requirement is different. And when you find mean, you are assuming everybody is the same. So that's sometimes you are introducing the problem. But if you want to consider only for, if there is such a reason, maybe you can find mean for FSKM student, just consider that kind of student. So that's why I say it depends on what your data is and the background of the study and also the literature. Okay, now the last part of the third module is actually about outliers. Now, as the diagram shows here, outliers, you can see that it is different from the others. So among the red roses here, we have the yellow roses. So that is an outlier. Now, in terms of number, extremely large values or extremely low values, that are outliers. What are the causes for outliers? It may be data entry problem, or measurement error or instrument error, or sampling error. Sampling error, that means maybe you have intended, for example, you want to take weight of athletes, but you have mistakenly chosen what are the people who apa panggil yang angkat berat tu, weightlifters kan, in the sample. So of course their weight will be definitely higher than those other athletes. So that means that the outlier is because of the sampling error. Or data processing errors, if you collect information from multiple resources, when you process them, you might do some error. Or sometimes it may be natural. It is like Bill Gates' income. It is definitely high. So that is natural or correct value, but it's naturally happening in the data set. So how to detect? You can do different plots here. The one that I'm showing you here, if you use box plot, you will see the outlier here. And you can use the command find to find where the values are. And if you plot scatter plot also, you can find outliers if it is further apart from the others. Similar here from histogram also, you can see majority of the data falls in the left hand side, but there is one extreme case on the right side. These are all outliers. How to handle depends on what you're doing and what the data is. But if you are doing regression, the plot will basically tell you what to do. If you know that the data is wrong, for example, if you take measurement for weight of adult women and you find that in the data set 19 kilogram, which does not make sense, that means that might be an error, so you delete that case. If it is possible that if it comes from the questionnaire, you can go back and recall or recover that value and you can do it again. Okay, but otherwise it becomes missing value lah. Okay, for the diagram first here, if you notice here, if the scatter plot here, the outlier is the one in the upper right corner of the diagram here, but you see that the regression line is not affected by that outlier. So here you can delete it because it does not change the assumption. But if the second diagram here or the third diagram, the outlier may change the assumption, so you cannot delete it. You have to study further why is that happening and so on. Now, if you also think that the outlier is not going to happen in the future, for example, age, you have people with age 150, which is sometimes not possible, or in the future you don't see it happening, you can delete also. You can change and assign new values for the outliers if you know the reason. You can change if you know the reason. For example, if you have experiment where you measure using a voltmeter and you know that the voltmeter is faulty, so you can repeat it back. So this one you can change. Or you can transform the data. Transformation here more maybe refer to in mathematics, if you take the square root of values or natural log, sometimes it will reduce the variation caused by the extreme value. So you can do that. You do transform the data. The command is like we did just now, you compute, but it falls under function on the right side. If we have time afterwards, I will show you how to change or to transform to log. Okay, but other times maybe if you delete or you cannot recover, you may change the data or the nature of the data. So you might leave it like income. Most income data always contain extreme data. So if it is legitimate and you can leave it in and decide to use other methods in your analysis. For example, instead of mean, you can use median. Instead of parametric test, you can use non-parametric test if it is necessary to leave it in. If it is possible to delete, then delete. And sometimes what people do is that they do not delete the data or the variable before they investigate why is that happening. Okay, because sometimes it will give you information that is important to your company or to your research. The example that I give here, if you have data for delivery, the time to deliver, that means usually take 1 or 2 days, but there are instances if you look outlier maybe a few months, or there is data more, instead of 1 or 2 days you have 1 or 2 months, then that is becomes outlier. Then you must understand why does that happen before you can do anything to it. You find out because it will affect your performance in the company. Okay, you have to, before you delete, you must investigate first. Okay, any questions so far? Now we have our last module is about the, we have about 1 hour. Let me look at the check box. Any question or not? There's no question here. All right. Everybody still okay?
Prof?
Yes.
Okay, just nak confirmkan dengan Prof. So, satu untuk yang tadi punya lah, kalau kita recode into different variables, maksudnya kita macam nak come out dengan satu variables yang baru lah kan daripada data kita.
Okay.
Tapi kalau recode into same variable tu, adakah dia sama kalau kita just tukar kita punya values dekat variable view ni?
Let me understand what you're asking. Okay. Let me go to the data here. Okay, here. What you mean, instead of we changing the recoding the textual to textual new, you just put textual to textual new, but you do same variable. We can do that. Let us try. Recode into same variable. Let me do here. Textual is the, is that correct? Okay, on you can do the same thing. 1 to 5, you do the same thing, but notice here for textual, I hope I did click the right value. The data here is 4. Let us see what happens if we do. Answer. What is it? 1 value to add. Why is it not accepting? Okay. 2 to become 4. Kenapa ni? 2 becomes 4. Okay. 3 becomes 3. 4 becomes 2. 5 becomes 1. Okay, you add. Continue. Click OK. Okay, you look at the data back. Example 1. See now that the textual now, instead of 4 becomes 2.
Oh, okay.
So that means you have lost the actual the earlier part, earlier data entry 4, 4, 2, 3, right? Now you don't see that anymore.
Okay.
But you can do that, no problem. But as long as you know that you have done it, if that's why some people like to do using syntax, so that their every step is recorded. Now, if you look at our output, let us look at our output. When you record, actually they will give also you the information here. See that you have recorded here. They give you the information. You have record textual 1 equals to 5, 2 equals to 4. So you must remember lah that you have done that change. So depending on you, but I don't trust my memory, especially if I have so many variable. Then when I recode into the same variable, I do not know whether I have done for all or I have skipped. That means I cannot check. So but it depends. That is preference, but I prefer to do it into different variable.
Okay. Thank you, Prof.
Any other question before we look at the last part of the section? Okay, let's look at the last part. This is talking about statistics. Here actually for the exploratory, you can do a few things, among which we can do the screening, identifying the outliers, checking assumption and so on. But we're going to focus on checking the assumption. Okay. To do that, I also need to cover some basic statistics, but I'm not going to go into very much detail. If you need any explanation for any of this, we can do it also, but I'm going to briefly cover it. Okay. So in under descriptive stats, we will have measures of frequency, the frequency table that we have looked at just now. And then we also have measures of central tendency, which is the mean, median, and mode. If you have ordinal or nominal data, you cannot calculate the mean. Okay. For nominal data, you can only calculate mode or identify mode. For ordinal data, you can find median. You cannot calculate mean. But if you have the interval data or the ratio data, you can calculate mean. For measure of dispersion or variation, we have variance, standard deviation, standard error, quartiles, interquartiles range, percentile range, and coefficient of variation. Again here, measure of dispersion is only for interval and ratio type of data. Okay. So for categorical data, which is ordinal and nominal, you cannot calculate that. Now, a little background on measures of tendency, central tendency. The most common one is the mean. The mean is easily understood if you look at the diagram here. Everybody gets equal. If I have 20 ringgit, you have RM30, the mean is 25 because everybody gets equal. Okay, that is meaning of mean. For mode, in the diagram here, if you go to a store or to a storage where we have different sizes of clothes, usually the store will have the most common or the most demanded size. Let's say medium. So, sorry, not medium, medium size. Medium size. So the mode is the most common value, which is the medium size. Okay, for the median, it is the center, like the roadside here. If you have in the highway, the center is the median. So if you have a set of data, if you divide equally, take the sum, divide equally, you have the mean. If you arrange it, the middle will be the median. The most common data will be the mode. Is that okay or not? I don't want to go through so much technical, but I will show you the formula of the mean afterwards, okay? Because that's the most popular one. All right, this is the mean. The mean is the most popular measurement of central tendency. Notice that the symbol here for sample and population, there is difference. Sample mean is denoted by X bar. Population is denoted by mu. Okay, population mean. The symbol, the calculation is almost the same. You just add the data, all the data added, divide by the sample size or divide by the population size. You total everything and then you divide by the number of data. That will give you the mean. Okay. Any question about the mean? Okay. In a report, the data you report in your paper or in your thesis is always the sample data. So it will be the sample mean. It will be denoted by letter M, I think. Okay, for mean. Okay, for measure of dispersion, it's describe the spread. I chose the diagram here, the image of the mouse, the teeth there. Notice that the teeth are quite further apart. It's not very the gap. There is gap in the teeth. So that is describing the spread. So in terms of data, this is measured either by variance, standard deviation, range, and the interquartile range. The most basic or the most popular one is the standard deviation. Now, how to comprehend this one? If you say, let's say we have data, let's say I ask you how much money you have today, everybody says 50 ringgit. So 50 ringgit, that means everybody have the same data. So there is no spread of the data. That means if you calculate the standard deviation, it will give you a value of 0. Everybody in the set has 50 ringgit. Standard deviation, 0. But that is unlikely to happen in the real life. You will always have differing data. So that's why standard deviation will give you a value. Variance is just the square of the standard deviation. Okay. The range is the difference between the highest and lowest value. Interquartile range, difference between the third quartile and the first quartile. We will not touch too much on interquartile today. We will focus on standard deviation. Okay, the formula is this one here. This is the simplified version. I would like to highlight you the most important difference between the sample standard deviation and the standard population standard deviation is that the division here is divided for sample n-1, but for population it is divided by n. So there is difference in the formula. Okay, but the sample standard deviation formula here is actually the best estimate for the population standard deviation. So you don't have to worry too much about this one, the formula, because you're not going to calculate on your own. Everything is given in SPSS or other package. Okay, if you have two sets of data, you want to compare. Now, the image of the teeth here, which one have more spread? if you compare between A and B, which one is more spread?
A.
It's clear here that there are gaps in the teeth in A but not in B. So A is more dispersed. Okay, so in terms of calculation, if you want to compare two sets of data, let's say between male and female, you want to compare which one is more spread, you must look at the mean first. Okay, let's let us look at this two example here. Set A, set B, nothing to do with the text just now. The data in set A, notice that the numbers are very close to one another, 3, 6, 7, 8. There are repetition, no problem. Set B, they are also closely to one another, 3, 6, 7, 8 is close to one another, but there is an outlier here. This is outlier 300. So if you calculate the mean, you add all these values and divide by the number of data. Here we have 2, 4, 6, 8, 10 data. So if you total this value, you get 60, you divide by 10, you get 6 for the first set. But because of the extreme value for the set B, you have 12 data, but the mean is 30.58. So if you notice here, the outlier or the extreme data has affected the value of mean. So if in your data set, when you run the frequency, you have extreme data, you should not use mean to represent the measure of central tendency. You do not report the mean because you know there is extreme data. Okay, so you should use either the median or the mean. The median or the mode. For set A, the median 6. How to identify the median? 6 here. The data is already arranged in ascending order, increasing order. There are 10 sets of values here. So the median happens between the 5th and the 6th position. 2, 4, 5th is here, number 6. 6 is also 6 here. So the median is between 6 and 6, which is 6 lah. You take the average between the two values here, which in this case, because it is both 6, the median says the 6. The same, 6. The mode is the most frequent here. 3 happens only 2 times. 6 happens 4 times. 7 happens 2 times. 8 happens 2 times. The most frequent is the one that happens 4 times, which is 6. So that's why the mode is 6. For the second set, if you notice now the median is 6.5. There are 12 data here. The median happens between the 6th and the 7th data, which is 6 and 7 here, the center. So when you add 6 plus 7 divided by 2, you get 6.5. How to get the median again? You arrange in ascending order. You have 1, 2, 3, 4, 5, 6. The position, first, second, third, fourth, fifth, 6. The 6 has a number 6, the 7 has a number 7. So you take the average between the two, 6 plus 7 divided by 2, you get the median value. The mode is still the most frequent, which is number 6. So the median and mode both do not change because of the outlier or extreme data 300. Okay, standard deviation, we substitute using the formula there. Notice that you have 1.76 and the second set 84.86. There are quite a large difference here. But you do not just base on this standard deviation to compare. You need another value which we call coefficient of variation. Labeled as CB, it compares between the standard deviation relative to the mean. So you take standard deviation, divide by the mean and divide by 100. So you get in percentage. For set A, you get 29.3, but set B 277.5%. So here the more spread value is of course set B, because you notice here that that because of the value of 300, it also affect the standard deviation, it becomes large, and therefore the coefficient variation also gets very large. Okay, to compare two sets of data, if we have different mean value, you compare using coefficient variance. The range also tells you about the spread of the data. For the first set, the difference between the highest and lowest, 8 minus 3, 5. 300, second set, B, set B, 300 minus 3 is 297. So you know the range will tell you that one set of data is more spread than the other. Okay, now to in the SPSS. How to find the descriptive stats. Now let's go to our SPSS. We take the employee data.
Prof, we have one participant who raised her hand, Dr. Erniza. Is there any question?
Okay, Dr. Erniza, what's the question?
Assalamualaikum.
Waalaikumsalam.
Okay, PM Rana. Actually, I have several questions here regarding of the descriptive analysis. As you mentioned that there is two different sample means, sample mean and population. So if and in research terms, which one is the best approach, or in which scenario for us to use sample or the population? So I'm quite unable to understand about the meaning of the sample and the population, because basically we just use the sample size. Can I have any regarding of the discrepancies between the sample and population?
All right. Okay, let's go to the slide just now. Okay, now in research, your population will be defined according to the objective of the study. Who are you going to study? For example, if we take our scenario in UiTM Perlis, let's say I want to study UiTM Perlis to study habits during the PKP or online study habits of all UiTM Perlis students. So the population is all UiTM students in UiTM Perlis, because that's the one that we have set, the objective. And I don't know what's the number now, maybe close to 7,000 students altogether. But in our study, usually we will not study the whole population, simply because we don't have the resources, the time and the money and the energy to study the whole population. And in science, sometimes it's almost definitely you cannot take the whole population to study. So what you do is you have to take sample. So if you do that, that means the calculation will always be sample mean. Let's take another example. Let's say we are studying the participants of today's SPSS. We want to find out maybe the understanding of the material today. We produce Likert scale instrument measurement for measuring that. So if our participants today is 70 people, we have 106 today now in the participant. If we study all 106 people, then that is the population data. But to study 106 students, it's possible because if we have a Google form I give to everyone, you can quickly answer. But if I do not study 106 students, that means let's say I want to speed up the process, I only ask 10 of you or 20 of you or 30 of you. Let's say 30. I ask 30 of you to answer. So if I ask only 30, that means we are only taking a sample. So when we calculate mean from 30 people, it becomes the sample mean. So to summarize, most of the time, we do not study the whole population. We only take a sample from the population, and the way that we select the sample should be randomly selected so that we can use the information to infer or to generalize the result to the whole population. Is that answer the question, Dr. Amiza?
Okay, thank you, PM Rwana. Okay, maybe in the simple way, it is some percentage out of the whole population. Is it right?
Okay, the sample is sub of the whole population. Sub.
Okay. Okay, PM, another one regarding of the variance and standard deviation. Sorry,
Okay.
I'm sorry because I'm not familiar. I'm using this kind of the terms, but I'm not sure about the purpose of the standard deviation, the variance. Okay. Usually, when reporting in terms of the best or the goodness of fit of some formula, okay, basically they use the standard deviation. But in which value or the record will shows the good numbers ataupun the good forecasting. Okay, means that standard deviation is near to zero or something when we have a very big numbers of the standard deviation. So it is good to model or to show what is the best of the formula that we use. Okay, so which one is good to report, either use variance or the standard deviation? As compared in the two different data in your slide, so set A and set B. So set B have very huge numbers of the standard deviation, 84, while the standard deviation for the set A is 1. So how can we conclude based on these two different reading?
Okay, if you want to compare between standard deviation and variance, usually we will use standard deviation to report because it is in the unit of the data, the original data. What I mean by that is that if your data is collected in kilogram, unit of kilogram, standard deviation gives you in kilogram. Like for here, 1.76 is in kilogram. But variance is square of that. So it is in the square unit. So it is quite difficult for the reader to comprehend variance in the original unit. So we usually report the standard deviation instead of the variance. Now, as in terms of the meaning, which one is better, or rather not better, if I understand what you are asking, what does it mean when we have a standard deviation of 1 and 84.86 here? It is actually telling you about the data. Let's say if we have, let's say we have a data on student performance, let's say student performance. And we have a standard deviation of 3. For another group of data, we have a standard deviation of 6, for example. But the mean for both group, let's say, is 50 points. Okay, I repeat again. In measuring student performance, we have a test of maybe a maximum of 100 score, and we found that the mean for both group of the student, let's say 50. And then one group, group A, standard deviation is 1. But group B, standard deviation is 5, for example. So 1 and 5 is actually telling you how far the performance or the marks of the student from one another. If it is very close, like 1 as compared to 5, you know that the performance of student, if, the mean is 50, the performance is very close to one another. But if you have a standard deviation of 5, that means you know that the marks are spread. Even though that the mean of 50 is 50, that means you might have people having marks further apart from the mean. Can I use the, let me.
So means that if the standard deviation shows big numbers, so it shows inconsistent result, PM Rana?
The word inconsistent there is, I'm afraid you might misinterpret what it means. It basically tell you how close the number are with one another. The data that you get, how close are that they all together. That means if we take the extreme case just now, if we have 5, number 555, that means there is no spread at all. So that when you calculate the standard deviation, you get 0. So you know for this group of students, there is no difference in their performance. But in another group B, for example, you have a standard deviation of 5. That means even though that the mean is 50, or if we take 5 just now, but the standard deviation is 5, that means you might have people having a value of performance of 10 or 9 or 0. That means they are more further apart. So if you want to check consistency in terms of value, I think the best way is to compare the coefficient of variation here by comparing between the standard deviation and the mean, so that you do not misinterpret in terms of consistency. So a smaller number means they are consistent to one another. The data is more consistent to one another as compared to a higher coefficient of variation. That means they are further apart. I hope I am as you get the explanation. But in terms of when you say whether which one is best, it depends on what you define as best. In terms of forecasting, to measure usually if in time series, we might find mean square error measurement or mean absolute error. So I don't know in your field of study, when you talk about error or the best method, I don't know what you are actually referring to. But in terms of consistency of the data, how close are the data to one another, you either compare with standard deviation or coefficient of variation, depending on whether the group have same mean or different mean. There is a question here. If the standard deviation is smaller, does it mean that the data are less spread? Yes.
So means the smaller is the best lah, PM.
The smaller means less spread. That means in terms of forecasting also, when you calculate mean square error, actually is finding the error, but you take the mean the difference between one value, the forecasted value and the actual value. You take the difference and then you average it out. So you call it mean square error. The square is actually comes from the negative value, but it is squared to get rid of the negative value, but you take the square root back again so that you get the data in the original unit of the data. So smaller value in terms of forecasting also, if you measure it by mean square error, smaller value is better.
Okay, means that if we use RMSE, MAE, MAPE, so it's better to compare which one is the best is using the CV and the standard deviation.
No, in terms of forecasting, if you use mean square error, mean absolute error, root mean square error, you take a lesser value of that.
The lesser value for the SD.
For the mean square.
Oh, for the mean square.
Mean square, you take there. Do you report the standard? I don't think you report for that kind of finding error in terms of forecasting. You report the standard deviation. Do you report that?
Sometimes when we use the regression, the multiple regression.
Oh, for multiple regression, yes.
Yeah, but for the RMSE, MAE, usually we just compare based on the error lah, the percentage of the error.
Yeah. You take
So
the
in this
smaller one.
case, in this case, we just use the descriptive analysis, so we can choose. Be better to reporting the value of the SD and the CV.
Yes, but there are other validation. You have to validate your forecast. What I'm saying now is that after you have validate values, then when you do comparison, you take the smaller value of the mean absolute error or root mean square error. But the validation process has already been done.
Okay, terima kasih Prof.
For the forecasting. All right, where were we? Any other question in the chat? Or is it compulsory to state all mean, mode, median variance in the study? No. Usually the most common reported value is the mean and standard deviation. It suffices by the two value because it will tell about the spread and also the central location, provided that you do not have highly skewed data. If you have skewed data, you will also state the skewness of the variable or data values. And then also if you have qualitative variable, you will not report mean because you cannot calculate mean. You will use mode. And if you have outliers, you will use median. So you will decide what to present based on your data. You have looked at, just now when we explore, we have identified the outlier. We have also looked at the measurement level. So that's why the understanding that we have on the type of measure, whether it's ordinal, nominal, interval or ratio is important, because that will also give you a clue on what to present, whether to use mean, median, mode, and standard deviation.
Right, Ramna.
Yeah.
I would like to remind you that we only have 20 minutes left.
Oh, yeah. We have quite a lot. I have not gone through the, let me show you the next slide, which is what? Okay, we will skip this one is, I think the practice is just to run the command here, how to get the,
maybe we can proceed first before we entertain any more questions.
Okay. All right. So now our next slide is actually we want to use descriptive stats. We have used this now, but we click under frequency. I show you so that we can go it through quite quickly. Okay. let me quickly show you the same command here under descriptive. You have frequency, you have descriptive, you have explore. These three you can use. Now to run, to see whether you have outliers and so on, just now you can use frequency to detect the error also. Descriptive also can give you the information about the mean, median, mode and so on. But I'm going to show you here now is on the explore. I think I can do that. Okay, let me go to this one. Let's say we take current salary. We have options here. So we have here, we can find mean, minimum, maximum, standard deviation, range. We have also kurtosis, skewness, but we do not have mode and median. Notice here we don't have. So that's why for getting the median, you click analyze, descriptive, you take explore. Okay, for explore, now if you take current salary, for example, to be the dependent list, or let me take the same one as the slide so that you can follow it in the slide. Month sales higher, you can click statistics. Here you can ask for outliers if you want. Okay, but it can be easily, if you want, let us click and see what the output gives you. And you click plot. Here you can ask for stem and leaf, but I'm showing you how to find histogram. You let this one factors level together for now. Now we want to also check whether our distribution follow normal or not, because for majority of the statistical analysis in parametric test require that the variable or the data to be normal. So that's why you need to do the test. Okay, normality with test, you can click that, you click continue, you click OK. Okay, what did we do just now? We click analyze, descriptive, and then we choose explore. Okay, and then you click there the histogram and also the test, normality test, and then click OK, and then you can now look at the output. Okay, now here notice because we have clicked that one, it gives you the descriptive where it gives you the standard deviation, the variance, median, mean, and also the range, the kurtosis and skewness also given. Because we have requested the extreme value just now, it also tells you what are the cases, number cases for extreme values, and then also give you the normality test, which I will comment in a little while, and then gives you the histogram and gives you the QQ plot. These are all to determine whether we have a normal curve or not. And then we have the next one. Where is it? Oh, I'm going to the navigation. The next one I want to show you is the box plot here. Month since higher. This is the box plot given. Okay, let me go back to the slide. Okay, let me go through this one. Okay, here we have, we can ask for the frequency and the charts and all the values. Okay, if you want only the, without the test, you want the mean, median, mode, you can go under frequency, and then in frequency you choose statistic, you can ask there, and you can also go to charts to ask for histogram, bar chart and pie chart. So I want to make a quick comment here. If you have qualitative data, then you cannot ask for histogram. That means if you have ordinal, nominal, you cannot ask for histogram. You should ask for bar chart, or if you want pie chart. Okay, and then always end by clicking continue, and then finally you can click OK to get all the values here. I want to explain the meaning. So they give you the output similar to the one that I have shown you just now. And then this is the histogram. And we skip the practice, you can do that later. Okay, now we want to talk about checking the normality. We have two big methods, either use the graph or you can do the test. There are two types of tests, Shapiro-Wilks and also Kolmogorov-Smirnov test. The graphical method is basically looking at the box plot, histogram and QQ plots. There are also PP plots that might be covered when they cover regression. Okay, now the image that I show you here where the mean, median and mode value are the same value, this is a normal curve where it centers at the mean, right? The area on the right side similar to the one on the left side. Okay, we quickly see here, if you want to get only the box plot, you click at the menu bar, graph, and there are two choice. You can use the chart builder or the legacy dialog, but I advise you to use the legacy dialog because that's the simplest method. And then when you click that, you have options of finding a bar chart or line graph, area graph, pie chart, and also box plot. So when you want box plot, you click simple case if you only have one category here, and then you finish it by define. When you click define, they might ask you what variable you want, okay? And then you will get this box plot. The outliers are represented with the dots here, okay? And the box plot here, because this is only for one variable, it looks a little bit wider, but it tells you that it is, when I look at this one, this is not normal. We want to see afterwards how does a normal box plot look like, okay? But now we go through the histogram, same command, you go graph, legacy dialog, you choose histogram, same variable, you will get this plot here. And if you compare with our normal graph just now, curve, you cannot tell for sure whether it is normal or not. It looks okay, but there are some gaps here. If you notice that where I'm pointing here now, there are gaps here, so it might not be normal. So we need to check. By visual inspection, sometimes you cannot make a conclusive conclusion. The QQ plots is like a scatter diagram. When it is normal, it should be centered. It should center very closely to the line. Okay. So if you look for our distribution here, there are two distribution here. Is it normal or not? If you compare the two with the normal curve, the first one is definitely not normal because it's skewed to the right. We have majority of the data in the left hand of the distribution and some extreme data on the right. So this is skewed to the right. The second one, there is two, it might look like it is bimodal because there are two high bar here. That means mode, there are two, maybe there are two modes here. So it does not deviate too much from a normal distribution. Okay, but again, visual inspection, sometimes for this case it's okay, but sometimes it is quite inconclusive. Okay, test of normality, I want to highlight the null hypothesis is actually saying that the variable follow normal. The alternative, it says it does not follow normal. To decide to reject and not to reject null will be based on the p-value. If it is less than 0.05, you will reject null. If you reject null, you conclude it is not normal. We want normal distribution. So we would want that the p-value for normality test to have a high p-value. Okay, this is rule of thumb for any of the tests. In the next session of SPSS, we will cover this for hypothesis. But the rule of thumb, p-value less than 0.05. If you set alpha to be 0.05, then that is showing that you reject the null. For this case, rejecting the null means you will conclude the variable not normal. We want a normal distribution. Okay, now let us look at the test just now that we have run. When we click analyze, descriptive, stats, and then take explore, and then choose the plot, choose the statistic like we did, then the output you get is this one. Remember this graph here? Now it looks almost normal. When you look at it carefully, it is normal. But actually, the whisker at the bottom here is actually longer. So it is not exactly normal. So what are these values representing? The lower part there here, the line is actually representing the minimum value in the data set. And then the next one in the bar, in the box, is the first quartile. The center line is the median. The other end of the box is the third quartile, and the whisker, the last part of the whisker, is showing you the maximum value. So basically from this one diagram, you can see the minimum, maximum, and immediately see the range, and you know that the median is exactly at the center. The diagram that I'm pointing now to you is the gray one. This is a normal distribution box plot. So notice that the whisker is the same length. The median is exactly at the center of the box. Okay, this is a guideline to know whether it's skewed to the right, skewed to the left, or the symmetrical. For me, I will always look at the longer whisker. Notice here, for the first diagram on the right, the whisker is longer, so skewed to the left. The third diagram, the whisker to the right side is longer, so skewed to the right. The center diagram is balanced at the right and the left side, so it is symmetrical. So from the box plot, you can tell it is skewed or not skewed. Okay. Similar to the QQ plot, this one there are deviation. If you look at the lower bottom of the diagram here, there are the deviation. So that means this is not exactly normal. Okay. The output, if you notice the skewness and the kurtosis given here, if it is normal, exactly normal, it should give you a value of 0 or close to 0. So here notice the skewness is close to 0, but the kurtosis is not close to 0. So this one is telling us that it is not normal.
Prof, what is kurtosis?
Kurtosis is measuring the pickedness of the graph. The pickedness of the graph, that means whether it is high, if you imagine a building, whether it is peak at the center or it is a little bit flat. We have different names for the kurtosis, either it is mesokurtic or leptokurtic or platykurtic. So but basically it's telling you how high is the graph. Okay, for a normal distribution, it should be in somewhere in the middle. So in terms of measurement, it should be close to 0. All right, and then now the test. Now, even though that the Kolmogorov-Smirnov test is actually used for sample size greater than or equals to 50, the Shapiro-Wilks is used for less than 50 sample size. Actually, there are some arguments on this one, but because our sample size is high for the employee data, so that's why I'm reading from Kolmogorov-Smirnov test. So notice that the significant value, which is actually giving you the p-value, 0 here does not mean 0. For SPSS, a value of 0 is actually representing that the p-value is small, is very small. It is in fact smaller than 0.0005. So when you report your test, you will give the statistics and the degree of freedom and the value of the statistic. For Kolmogorov, the test statistic is D. For Shapiro-Wilks, it is W. The degree of freedom is given here, the same. The significant value also is less than 0.05, therefore you reject null. When you reject null, remember just now, null, data follow normal. Alternative, data do not follow normal. P less than 0.05, you reject null, you conclude not normal. So you say here that the Kolmogorov test showed a significant departure from normality with the statistics and also the p-value given here. Or if you want to write, show that the data is not normal, also can. Okay, but there are arguments in terms of writing zero because there is no probability of zero. So some people, you can actually get the exact value by double click on the output, you get the exact value. If you need to report the exact value, okay, because some journal do not accept you writing it as p equals to 0. Any question on this one? Another point that I want to like to make is that if you have a sample size of more than 30, by central limit theorem, actually the data follow normal. However, it requires that you take that your sample must be randomly selected. Okay, so that's why you may find that Shapiro-Wilks is more commonly reported in reports or paper. Okay, because people sometimes, because this one, if the degree of freedom is high, that means that is showing that the sample size is high. So by central limit theorem, it is already normal. So you do not need to argue on that. But our test here show it is not normal. Okay. So this is the conclusion here based on the skewness, the kurtosis, the months is higher do not follow normal. In inspection of the histogram and the normal and the box plot also show it is not normal. Okay, but the most maybe significant way of doing it is giving the result of the test, that the p-value is less than 0.05. Okay, the example. Okay, that finishes. I think we have a few minutes. Let me see whether what is the question in here. The numerical test like Kolmogorov show no normal data while the graph shows normal. Is it still normal? The data just now, let me show you the data again here. The graph is this one. Now, if you look at the data, the graph here, it is not exactly normal. How does a normal graph looks like? Like here, the data will be spread here. It will very nicely placed here. Even though there is no bars here, you can imagine that the bars is superimposed here. It will be exactly following that curve, the symmetrical curve here. But ours here, notice that there are gaps here. Here, can you see my pointer here? The gaps here, if it is normal, can I use the Jamboard? Let me try, okay? How to use the Jamboard? Let me go to our Meet. Kenapa tak keluar? Where's the Jamboard? Okay, whiteboard. here, I cannot see. Okay. Okay, I hope I can use the pen here. Okay, let me. Okay, if it is normal, now the normal curve looks like this. Sorry if the graph is a little bit crooked here. That means if you have, I'm not using the pen very well here. Mine the graph, nampak kena tiup angin graph tu. If it is normal, the left hand side of the center and the right side will be exactly the same. Something like this. Okay, but if you look at our graph just now, there are bars here, but there are also gaps in between. So they are like that, right? The bars are like that. So that's why when you do the test, because is there a color here? Can I get color here? No. Sorry. Selalu tak guna Jamboard. Selalu guna. Okay. I don't know where the color is. This is the eraser. Okay. So I'm shading the gaps here. Okay. Notice here that the gaps that I'm writing here. These gaps here and somewhere else, if it is normal, it should not be there. The gap should not be there. So that's why, let me stop this one. Can you now see the slide? If you notice here, see the gaps here, the gaps here, all. This one, the test is actually measuring how well the observed values here deviates from the normal distribution. So that's why even though our eyes look at it as if it is normal, it is actually not normal according to the test. Okay, so may I ask to use descriptive test? Is it applicable to both probability and non-probability sampling method? Okay, now to use descriptive test, it is the same. It is the same actually. You can use all the measurement, but in your report you have to tell that the sampling was not done normally, not randomly. So you cannot do the inferential statistics part.
Right, Amrana, it's already 12:36 now.
Okay.
Can
I
we
actually finished already covering the materials that I need.
Okay.
But if
perhaps we can proceed to the question quickly in the chat box.
Okay. Do we have a different test if the data are not normal? Yes, you use a non-parametric test. Okay, where it does not depend on the mean and standard deviation. It might use the median. There are tests for parametric and non-parametric. So if you do not, does not satisfy the normality assumption, you go and do the non-parametric test. Okay. May I ask, okay, which test we prioritize, numerical or visual? Usually we will, if visual, sometimes it is not conclusive. So it is best that you present it using the test. Okay, what other question do we have here? If the p-value has 0.4 to 1, some of the paper indicate that this value, what can we conclude for the value of more? What if the p-value has 0.1? 0.4 to 1, that means you will reject null For normality test, we reject null just now if p-value less than 0.05. If you have p-value of 0.4 or higher, you do not reject null. That means you can conclude that the variable or the data to be normal. Okay. Some of paper indicate this value. What can we conclude for the value of more than 0.05? Is it acceptable, unacceptable? You will report accordingly, whether it's 0.04, 0.1, 0.5, you will report the p-value. But the p-value will indicate whether you will reject the null or not reject the null. That will depend on what you are testing. Acceptable or not acceptable is not the problem actually. You set your alpha level, most of the time people set at 5%. So if you reject, your conclusion is either according to what you have put in the null and alternative, the test, is it about one mean, about relationship, about difference, so depends on that. So there is no question of unacceptable or acceptable. You report as it is, and from then you will conclude whether there is difference, no difference, there is relationship, no relationship, normal or not normal. For the one that we are discussing now, if you do not reject null, that is good for us because you conclude that the data is normal, so you can do all the tests that require normality. Okay.
Okay, PM, can we proceed with one last question because it's
Okay,
already
one last
12:14?
question.
Yeah.
Okay, can we still run the test if the data are not normal? If the data are not normal, you use the non-parametric test. You can run the test that do not require normality assumption. If you find out that you can, based on certain argument that you have discussed that your sample is random, your population, the sample size is larger than 30, you can argue using the central limit theorem that the data is normal. If you argue that way, then you can still run the test. But if you are sending it to the paper or your thesis, the supervisor or the examiner might argue on the sampling method lah. So make sure if the sampling method is normal, you have done everything correct, even though that it deviates from normality, but the sample size is large enough, then you can run the the test. Okay, so I think we don't have enough time for other discussion. Maybe you can carry forward the question in the next SPSS
session.
In second part or the third part, you can ask there. But there are a lot of discussion on sample size, sampling method, and so on. So I think what we cover, I want to conclude today. From today, I hope you have acquired the knowledge on using the SPSS in terms of preparing the data. You can also run simple analysis like the graph, the descriptive stats, and to do the normality test also. So I think with that, if you have any further question, you can ask me after the session. And you can refer to the notes here if necessary. I think that's all lah for today. Segala kekurangan, kelemahan saya, yang baik semua datang daripada Allah Subhanahu Wa Taala. Sekian, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, PM Rohana, and also thank you for the questions from the participants. And highest appreciation to our speaker, Professor Madia Rohana alias. The session is definitely compact, informative, and interactive, especially for IBM SPSS beginners. Right, before we end today's session, could you please turn on your camera for a brief photography session? Could everybody please turn on your camera? All right. So, Mr. Naim, are you ready to take the photo? All right. On the count of 3, right? 1, 2, 3.
Sorry. Sekejap sebab ada message
Okay,
masuk
not
tadi.
ready yet. Okay.
Dia okay.
All right.
Let's
Okay. Okay, ready now?
Okay.
Okay. 1, 2, 3. Right. Okay, one more. Okay. 1, 2,
Sorry.
3.
Sekejap.
No,
Ada
no.
message masuk. Stop message sekejap.
Can you please stop messaging because it keeps popping up, so we can't screenshot the photos. Okay, thank you. 1, 2, 3. Okay, Mr. Naim. One more. Should we take one more?
Okay, can.
Okay, 1, 2, 3. Okay, we're done. All right. So thank you everyone. With that, the session we have reached the end of the first session for webinar writing series, Statistical Analysis using IBM SPSS. Please take note that the link to your certificate of participation or attendance is now shared in the chat box.
Thank you, Prof.
And, thank you again for everyone's participation. Hopefully today's session has provided positive aids and impact for your profession. With that, wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.